Welcome you all to our June FCC Technological Advisory Council meeting. This is obviously the midpoint of our year, and in fact I'll put myself up there so you can see that I am alive and well here. This is not only the midpoint of our year, but this is always the transition time as well. The first half of the year is largely devoted to information gathering. In the next quarter, our focus is beginning to really lock down some actionable recommendations, and obviously at the end of the year, those are the high focus for us. But this is the key midpoint of the year. I would point out that this is not only the midpoint of 2020, but this is the midpoint of our 22nd year as an organization, for those of you who are keeping tabs of such things. It's also a key time for us to be meeting. One of the things I know that is on all of our minds is the challenges that we're facing. The pandemic, which we thought was the most disruptive and difficult thing that we'd ever dealt with, and of course that immediately led into financial meltdown and huge unemployment and all of the ills that are following, and now into the unrest and the riots in the street and all of that. It's quite an amazing time, and it does weigh on all of our heads all of the time. But in that context, I reflect on what we are doing. It's really amazing and quite fruitful for us that we are moving forward, that we're continuing to focus on things that will enable us to move forward, to remain connected, especially in the craziness of the greater world, and to continue to conduct and move at least a significant part of the business affairs of the United States forward. So kudos to each of you for your ongoing contributions on a week-by-week basis with all the working groups and all of the things that you are doing to, even in the midst of craziness, you are working diligently to move things forward and to be a force for good. And that is greatly appreciated by me, and I think by the commission, and of course the commission itself is continuing to move forward. A lot of that is even that possibility, and this call is a great example of it. A lot of the capability to be as productive and effective as we are is based on the work that so many of you all, and maybe we all, since I've been involved in this industry for so long as well, all of the work that we've done enables the capability to not only have virtual meetings, this being our second virtual meeting, but also to conduct all forms of business in this virtual way. And that's a very significant contribution and accomplishment. Often we don't think about what we are doing in the greater world. We have heads down and we're looking at the next problem and concerned about what isn't as we would like it to be. But major contributions have been made by this group, and my kudos to all of you in the contributions that you've made. So with that opening and backdrop, we'll turn away from all of the craziness of the world and focus on the goodness of what we're doing. And let me hand things off to Ron Rapazzi to give us a word from the top on what's going on in the FCC and the things that are hot and what maybe is not, and how we are able to contribute and focus our efforts. So Ron, let me pass it to you.
Thank you, Dennis, and good morning to everyone. I can't express enough the amount of work that's happened in the TAC over the past several months. There have been a couple of things that have happened from the commission standpoint with respect to new technologies, not the least of which was the 6 gigahertz item that was released a couple of months ago now. This is to open up 1,200 megahertz of spectrum in the 6 gigahertz band for supporting new unlicensed technology. So there's quite a bit of work that has happened from the commission standpoint, and a lot of the representatives around this virtual table have been involved in supporting getting new technologies out to consumers for the public interest. So a lot happening in there. From the working group standpoint and from the tax standpoint, I'm rather excited about seeing the work continue over the next coming months on the different working groups. I've seen a very substantial amount of work that went into gathering information from renowned speakers and subject matter experts in the industries in each of the working groups. I'm very pleased to see the level of effort and the level of detail that has been going into preparing the presentations that we're going to go through this morning. But then going through the next couple of months, I plan to work with the liaisons and work with Michael and Dennis to try to begin to focus on what the actionable recommendations might be. Where are the areas that show the greatest promise for bringing some of the great effort that's went into the various topics to focus them in onto recommendations that could be arrived at and presented to the commission at the end of the calendar year. So again, my greatest appreciation for everybody that's involved in the TAC and all the work that's going in to develop these new topics. And with that, I think I'll turn it back over to Dennis. Thank you.
Terrific. Thanks, Ron. Thanks you for your guidance, and thank you for your focus as well on the TAC in the midst of all the other things the FCC is working on. I will just add that I appreciate all of the accomplishments, and I took special note, and this is sort of kudos to the unlicensed team, because you did go back, and Brian, I think this is a lot of your work, looking back at 2015 and the recommendations that had been advanced in the 2015, and how many of them had positive check marks associated with them. So it's an indication of how well the FCC both receives our input and takes action on it. So very, very rewarding to see that. And of course, I'm stealing some of the thunder from that presentation, but it's great to see that, and we'll continue to see that. I know in the future with the recommendations that come out of this year. Let me pass things on to Michael now to go through the logistics. I know some of you missed the critical detail that you needed to dial in for the meeting, as opposed to having it operate directly off the WebEx, as so often is the case. Hopefully, most people are on. We will determine that shortly as we do the roll call. But let me pass things to Michael to remind us all on the logistics and how we do tent cards in this virtual world and all the rest. So Michael Ha, our designated federal officer, if you would take over and make sure that we are whipped into shape for the meeting. Let me pass it to you.
Hey, thanks, Dennis and Ron. Good morning, everyone. Good to see everyone on the call here. So just as usual, the raising the 10 cards for your speaking opportunity is type your name on the chat box. Everybody should have a chat box with a few messages already, especially about the phone bridge. The reason we use this phone bridge is to avoid echoes. A lot of times, people are not careful turning on both microphone on your computers and the phones, and the echo problem is going to get a little bit difficult to control that, especially with a larger crowd. That's why we have a separate bridge for the audio. Also, if you're not speaking, please mute the phone to minimize any interference or the echoes. Also, as a reminder, that the FACA rules require only one member to be presented at the TAC meeting. So if you have a extra working group meeting members, and if they're on the phone, I'll suggest maybe participate the tech meeting through the SEC Live website instead of the being on the bridge. With that, let me just go through the roll call. First, I'd like to introduce the Manish Ghosh, our CTO. Manish, are you on?
Yes, I am. I was muted.
And also the Martin Doxcat, he's the alternate DFO as well. Martin, are you on?
Hi, yes, thanks.
Thank you. And we heard from Ron earlier, and going through the members. Brandon Aberley from Nina, are you on? Shahid Ahmed from Equity. Mark Bailey from Visual Link Internet.
Yes, I'm here.
Nomi Bergman from the bench.
Yes, I'm here. Good morning.
Good morning, Nomi. Lynn Cloudy from NAB.
Yes, I'm here.
Thank you. And Marty Cooper from Dyna LLC. Brian Daly from AT&T.
Yes, good morning. Brian's here.
And Satish Dhanasekaran from Keysight. Adam Droba from Open Tech Works.
Good morning, Michael. I'm here.
Thank you. Jeff Forster from Intel.
Yes, I'm here.
Morning, Jeff. Dick Green from Liberty Global.
Morning, Michael. I'm here.
Thank you. Lisa Guest from Cradle Point.
Yes, I'm here.
Good morning, Lisa. Russ Garrick from Cisco.
Present.
Thank you. Dale Hatfield, I saw you on the phone.
Yes, I'm here. Thank
Good
you.
morning, Dale.
Good morning.
David Hayes from Ericsson.
I'm here. Thank you.
Good morning, David. Mark Hess from Comcast.
Mark Hess is here.
Good morning. Peter Kunz from Boeing Company.
Good morning. Present.
Good morning. Kari Kwapamaki from T-Mobile.
Yeah, good morning. I'm here.
Good morning, Kari. Steve Lanning from Viasat.
Steve Lanning here.
Good morning, Steve. Greg Lappin from ARRL, American Radio Relay League.
Good morning, Michael. I'm here.
Good morning, Greg. Kevin Leddy from Charter.
I'm here. Good morning, Michael.
Good morning. And Brian Markwalter from CTA.
Yes, Brian's here.
Marla Medin from Google. Lynn Merrill from representing NTCA.
So I'm here, Michael. Good morning.
Good morning, Lynn. Paul Miser from Amazon. Jack Nezialski from Qualcomm.
Good morning, everyone. Jack here.
Good morning, Jack. Michael Nawaki from Edis.
Yes, good morning.
Good morning, Michael. Art Nichols from Windstream. Madeline Nolan from ATSC.
Madeline's here.
Good morning. Ted Rockefeller from NYU Wireless. And we have our chair, Dennis. Jesse Russell from Inc. Networks. Travis Russell from Oracle.
Yes, I'm here.
Good morning, Travis. And Hans-Jürgen Schmidt from Facebook. Marvin Serbu from Carnegie Mellon, serving as a special government employee.
Marvin Serbu here.
Good morning, Mark. Kevin Spark from Nokia Bell Labs.
Hi, Michael. Yeah, I'm here.
Good morning. And Vince Spina from Juniper Networks. And Paul Steinberg from Motorola Solutions.
Good morning, Michael. How are you?
Good morning. And Tom Swanabori from CTIA.
Yes, good morning, I'm here.
Hey, Tom, good morning. And David Cannonhouse from VMware.
Here, good morning, Michael and everyone.
Good morning. And David Young from Verizon.
I'm here. Good morning, Michael.
Good morning. And lastly, Charlie Zhang from Samsung.
Good morning. I'm here.
Good morning. So great. We have a great participation attendance for this meeting as well. And the agenda is shown here. We will start out with 5G IoT working group. We'll go through the 2 working groups. Break for lunch. Still working some logistics and technical details over this Potbelly sandwich drone delivery. So hopefully we'll continue to work on that, and then we'll have the other 2 working groups in the afternoon. So with that, Dennis, anything else before we jump into the slide?
No, I think we are ready, and I'm very pleased once again to have such a large attendance. It's one of the interesting features. We experienced it with our first virtual meeting, and we've really seen it again with this meeting. I think we somehow get much greater attendance with the virtual meetings, and probably because of the overhang of no one traveling anywhere as well. But it's really very gratifying how many people are in attendance at the session. So I think we can move forward. I'm not so sure about the Potbelly delivery, but we'll see what Michael does with that one. But let's jump into 5G, IoT, O-RAN, etc. working group. And Russ and Brian, please take it away.
Okay, thank you, Dennis. This is Brian. I'll kick things off for the 5G IoT working group. So if we can move to the next slide, we'll just give an outline of what we'd like to provide in today's readout. We'll go through some of the logistics of the participants and the chart of the working group and a summary of the subject matter experts and topics that we've had. We'll give a standards update, a view on the spectrum, O-RAN update, IoT update, and then look at next focus areas and potential areas for recommendations. Next slide, please. Again, we have excellent participation on the working group. I'd like to give a shout out to all that are participating in our weekly calls and providing input to this work. I'm not going to go through the list, obviously, in one by one, but I'd like to thank everybody for their contributions and participation, and of course to our FCC liaisons. Thank you for your guidance that you're providing us as well. Next slide, please. So the charter that we had originally from the FCC is listed here. Again, we've got a lot of areas that we were tasked to cover and areas to do an in-depth investigation on. I'm not going to go through the details on this slide. I think we've presented this before. But I just wanted to make sure we had it included here just for completeness and understanding. If we do go to the next slide, however, Russ and I and the group did distill this work down into 3 buckets, so to speak. The first is 5G, looking at development, deployment, and new technology drivers and so forth, as well as how 5G will coexist with unlicensed bands and services. And then looking at the future, because 5G will evolve, and eventually we'll get to a 6G. The second bucket is IoT, looking at the different verticals, focusing in on some such as transportation, energy, healthcare, and so forth, and what can we do to accelerate that. Also looking at the industry-specific needs related to spectrum when it comes to IoT, and the suitability of spectrum for verticals. And then the third area, third bucket is O-RAN, and this is looking at the potential to disrupt conventional cellular network design and deployments, how scalable is O-RAN, and so forth. I won't read down the complete list, but you can see there's several areas within O-RAN that we plan to cover. Next slide, please. So next, we'll look at the work plan and activity summary. So if we can jump ahead to the next slide. So looking at those different areas that were covered, we broke down into specific different tasks and looking at different areas that we would provide recommendations. First being O-RAN, and we wanted to frame O-RAN and collaborate with the RAN working group because there is a lot of overlap, as you would expect, between O-RAN when looking at a system level with O-RAN looking at the RAN level. So we want to make sure we have tight collaboration with them. We wanted to take a deep dive into the O-RAN Alliance since they're developing a lot of the architecture and specifications as well as open source for O-RAN related activities, as well as how that ties into what's going on within 3GPP. Specifically, we're interested in the adoption and market impact and timing, as well as the competitiveness on a global scale, some of the key challenges, and then finally, what actionable recommendations can we develop as a result of that. For 5G development and deployment, looking at the standards progress, impacting events, and what advice we can provide to the FCC on those. Technology awareness beyond 5G. There is already activities, as we mentioned at our last briefing, on 6G. So we wanted to understand what the emerging technologies are, what 6G planning is going on, as well as some of the non-terrestrial networks, as well as Wi-Fi 6, and some of the work going on in the ITU. In the 5G verticals and related impacts and needs, looking at specific verticals and how those impact or come into play when we're looking at 5G. Spectrum related to verticals, what are the specific requirements and spectrum policies on a global scale, as well as shared spectrum opportunities and assessment. And what are the competitive impacts here in the USA and what recommendations, again, could be provided. And then the other areas, the 5G impact related to unlicensed, specifically interference and coexistence, and any recommendations we may have there. Next slide, please. So during the course of the first half of the year, we've had a number of different subject matter experts come in and talk to us and provide us with some key insights. The next two slides are going to list those in a bit more detail. I'm not going to go through the summary of each one. These are only the key points that we pulled out, but there's a lot more detail in each of the presentations that we received. The first, Jack Murray from AT&T presented on the O-RAN Alliance and gave an overview in the status. Mike Naraki of Addis presented on 6G and the marketplace of the future. We had Preston Marshall come in and talk about shared spectrum and the CBRS Alliance. Preston's from Google. Paul Ditter from Cisco came in and talked about the IIoT and factory wireless requirements. And Rob Sony from Nokia came in and talked about the RAN Tech Talk and the joint session with the RAN working group as well. Again, I'm not going to go through the summary that's listed some of the key points from each of these talks. They're presented here on the slide. And if you do have any questions, certainly reach out to us or myself, and we can provide more information. Next slide, please. And then these are some of the other key speakers we had in. Sachin from O-RAN Alliance came in and talked about some of the more in-depth on some of the details on RAN programmability within O-RAN. Andreas Mueller from Bosch came in and talked about the 5G for factory wireless. We had John Baker from Mavenir talk about more on the O-RAN deployments in the wild. Ganesh came in and talked about precision timing and GPS evolution. Finally, Kumar gave us a spectrum overview, and Per gave us more details on O-RAN. So you can see we had quite a few talks on O-RAN, quite a few discussions on the O-RAN and the impacts of ORAN, since that is one of the key topic areas. Okay, if we move to the next slide, we'll jump into the standards updates. So you can move now one slide further, please. So again, coronavirus has really taken its toll on global standards development. Face-to-face meetings now are canceled at least through December, and I use the word "at least" there because there's no real clear picture on when face-to-face meetings will start again, or what face-to-face meeting requirements will actually be in place. With the coronavirus and all the global health rules that may be in place around that. 3GPP has defined special procedures for exceptional situations restricting travel. In other words, they've defined the procedures for electronic meetings and how to function with virtual meetings. This describes, in addition to the basic processes, but how you can hold votes and how votes will be conducted through e-meetings. And there also is a process to allow the leadership to call physical meetings when the situation allows. But any resumption of the face-to-face meeting cycle is not only dependent upon the virus being defeated, but also what other government and company travel restrictions may be in place. Overall, EE meetings have generally gone well. I think they've fallen into a good cadence, although it's very cumbersome to run some of these meetings through electronic means. When you normally have a 1 week face-to-face meeting, typically those are now 2 week electronic meetings. And you have all the emails and so forth associated with that. So it's quite a bit of a burden on the delegates that attend these meetings. This doesn't only impact 3GPP. All regional and global standards and industry associations are affected. I will point out that ATIS has by nature held many meetings virtually, so it's more business as usual for many of the ATIS meetings. But as you see there, the other global standards and industry associations have been affected by this. Next slide, please. So Release 16, that was targeted to be complete in March, but because of the coronavirus, that has been delayed to the June virtual plenary meetings. And I use June loosely here because, as I mentioned, going to electronic meetings has actually slipped the June plenary meetings into the first week of July. So in the upcoming weeks, we should see completion of Release 16, both for Stage 3 and the ASN.1 code that goes along with that. And just to refresh memory, the Release 16 has 5G system phase 2, includes V2X work, industrial IoT, includes the ultra-reliable low-latency communication enhancements, the new radio-based access to unlicensed spectrum, 5G efficiencies, as well as enhancements for a common API framework. So that work is expected to be complete in the coming weeks. And as you see on the schedule on the right, the Release 17 has already started, and some of the content, as we'll get into the next slide, has already been developed, and even Release 18 is beginning to take some shape. Next slide, please. So as I mentioned, the Release 17 work package is stable. SA2 has prioritized the Stage 2 work. Studies have begun. Very preliminary work on the studies have been done because a lot of the electronic meetings have really focused on completion of Release 16, and Release 17 is really just getting underway. Some of the content highlights, there's enhancements to slicing and edge compute, network automation and orchestration, narrowband IoT enhancements, drones, location services, new features for 5G proximity services, which is used for public safety as well as V2X, 5G multicast and broadcast, integrating with satellites, industrial IoT, and 5G media and virtual reality. And there's also some architecture enhancements and studies that are being complete as well. Next slide, please. Release 18. There's been a number of proposals that have been already submitted to SA1, which is the requirements group. During a meeting a couple of weeks ago, they actually went through and tried to prioritize and reduce the content of Release 18 because it's still uncertain about with coronavirus when they're going to get back to any sense of normalcy. So they're trying to identify and prioritize the features. Those that are crossed off on this list didn't make the initial cut. Those that you see listed there did make the initial cut and are some of the initial studies that will be undertaken in SA1 for Release 18. So let's move to the next slide, please. And with this, I'll turn it over to Russ. Russ?
Thank you, Brian. We're going to take a little bit of a shift here and talk about 5G spectrum-related topics. So first, to frame it up, and by the way, I noticed that at the bottom it's 18 of 143 slides. I assume you loaded the long version of our PowerPoint, but I think we only have 30 slides in there. So as we look at the growth of traffic, and
that's actually the total number of slides.
I was hoping
for everybody.
So. I don't know if I could talk for 3 hours, but as we look at the growth of traffic, and 5G is clearly about massive broadband support, things like that is one of the 3 pillars. But if you look at the from an Ericsson report on broadband, a very good report, by the way, that you can do some customized capabilities with as well. 160 exabytes of total traffic predicted by 2025. The U.S. portion of that is roughly 10%, growing from about 8.3%. So there's significant growth within the U.S. market alone in terms of worldwide demand. With some of this, the point about this is it also drives some of the need for a multi-spectrum approach or a spectrum diversity approach. Flip, please. Next slide. So a lot of things have taken place in the last, I would say, 2 years related to spectrum. And in fact, I would say the last 12 months have been extremely active. The FCC's done a fabulous job at getting some of these things sorted out and spectrum made available. And, going across this band, what we tried to do is summarize what's happening in mid-band, how much is available in high band. I think everybody's aware, high band, there were a lot of auctions in the millimeter wave section for the service providers. And then in mid-band, there's been some recent changes, including C-band, 280 megahertz was made available, CBRS. The auctions go live end of July on the PAL licenses, that is, GAA is already available. And there's some spectrum that's available in the WCS and BRS bands. What we were trying to do here was get a summarization of how much bandwidth is actually there. So in the mid-band, there's roughly, and I say roughly 564 because we're considering the full CBRS, which includes GAA, not just the license piece. And then when you look at high band, there's about 4950. Adding all that together, there's about 1200 megahertz. I shouldn't shortchange it. It's 1237 megahertz of spectrum that's available. If we could flip to the next slide. So there's an opportunity, and there's also a desire for additional mid-band spectrum. Mid-band, for the reason that mid-band's a sweet spot, I think talking to any service provider or even anybody who wants to use spectrum, mid-band has some great propagation characteristics. It has some great bandwidth characteristics. And so it is a real sweet spot. And when we look, this is a little bit of a summary, showing what's happened in BRS, EBS, CBRS again, in the C-band. But what's in the gray area is the opportunity in terms of potential repurposing or sharing of spectrum. And the NTIA is looking at this, working with the FCC. And you'll see the different uses that are there today from 3.1 all the way up to 3.5. And, there's significant, incumbent use cases there, but there's also opportunities for additional sharing. Next. So this is a little bit of a sort of a fun visual in a way. I thought it was fitting because spectrum is a bit of a ghost, and you have all these different Pac-Men going after the spectrum in terms of the different types of operators, from licensed, unlicensed, shared, private, and so forth. Spectrum diversity is really important, as I mentioned, when we're trying to solve the overall bandwidth needs and the different deployment type models that are out there. All users do want more spectrum, obviously. It's not something that you just invent. But mid-band is the sweet spot. It's also very limited, as we showed with the incumbents that are in that space. And I just pulled out one of the bullets. There's a link to the bottom, but there's, in terms of the FCC management, spectrum management policy, there's 21 bullets that are listed there. This is just one of the bullets that I sort of paraphrased, and it really talks about what is best use of spectrum and promotes fair, economic, efficient, and effective management policies while avoiding harmful interference. I may have combined the harmful interference with, I think this is it's a low number. It's like 2, 3, or 4 on that list. But, this is a real challenge for the FCC in trying to do this management of spectrum. We also want to look at how do we have a future-focused plan. We all know 6G is coming, and we're going to talk about that a little later in the presentation. Next. So in the discussions with the team, there's probably more sliders than this on the sort of artificial equalizer here, if you want to call it that. But the 3 key critical factors really are spectrum, densification, and spectrum efficiency. And each one of these, there's trade-offs, as I mentioned. So adding spectrum, it's very limited. It's challenging based on availability. So that's kind of like a really controlled amount of sliding you can do there on that button. Densification, it helps, in terms of getting more out of existing spectrum, but it's very costly as well because of the additional equipment and so forth. And it also is somewhat spectrum tied in terms of what, how much you can put densification in. Spectral efficiency is one that will help, and however, it's difficult, or I should say challenging technically, as well as it's costly to implement potentially over time. So really a balance of these has to be driven by deployments. Next. So some of the next areas that we're going to explore on the TAC team are really focused on some of the additional shared options. Mid-band is obviously a priority. We're going to take a deeper dive on that from a SP use case and need. We'll also be monitoring the success of what happens in July when the CBRS PAL licenses are let out or auctioned. And we'll also do a deeper dive on some of the IoT verticals. I'll be presenting IoT in a few minutes. And some of those related requirements and spectrum needs potentially. And we'll explore new and emerging technologies that can drive spectrum use efficiencies as well as one of those sliders that I mentioned. Future view, we'll take a look at what 6G needs, what the opportunities are. There's a lot of talk of very high millimeter wave. We'll consider the full network architecture from the UE to the core because there's quite a bit of virtualization and densification going on in O-RAN. And then the applications requirements tied to spectrum needs per band as well, and data-driven approaches to both licensed uses and shared environments. Next. So I'm going to transition to the RAN, O-RAN, and vRAN next. And just to level set, there's 3 definitions here that people need to be aware of because sometimes they're used interchangeably and they really shouldn't be. Open RAN is really a disaggregated RAN functionality, and it's built on sort of open interface specifications between elements. The difference between Open RAN and ORAN is very much a clearly defined effort by the ORAN Alliance. So it's kind of a term that's totally tied. There's a great deal of overlap between the two, but the ORAN Alliance is really a specification group that's putting in place everything from the type of split of how to do that architecture and defining some of those capabilities, where Open RAN is more of a community developed standards. And then you have vRAN, which is the implementation of the RAN in a more open and flexible architecture and virtualizes a great deal of the network function and some of the software platforms. And there's parts of vRAN that apply to ORAN. So next. And this is a high-level architecture of ORAN. Next few charts are going to talk about more detail how this works and some of the architectures. But again, it's based on well-defined standards interfaces from 2GPP, looking at open interoperable supply chain ecosystem. And it's also focused on reduced cost through using COTS hardware and virtualization of the software. Next slide. And one of the things that's interesting here too is how ORAN has defined what's called the split option of 7.2. This is, it's the current split that's defined. It's not saying there won't be additional splits defined by ORAN Alliance. There probably will. At least, one of our speakers, our SMEs, Sachin Kadi, mentioned that in one of the talks we had. And there may be a number of splits that apply to different type use cases or verticals even. There is a trade-off between open RU and complexity in the interface throughput. The 7.2 split, by the way, is a specification for functional splitting between ORAN distributed unit and ORAN radio unit. It's been adopted by ORAN front haul specifications. And I'll dive into a little deeper view of that on the next slide as well. Also, the emerging RU vendor ecosystem has pre-commercial deployments by Tier 1 announced, and we'll talk about those next. So this is the logical diagram, and if you look where that 7.2 split is, the second bullet on the left there, you look between the open DU and the open RU is really where that open front haul split is defined. If you take a look to the right, there's 3GPP interfaces that have been defined, and there's a number of open software stacks that now can be applied to the RAN in this implementation. This gives a lot of flexibility to service providers, creates more competition in the market, and drives different, more agility in terms of use cases and deployments. Next. Some of the observations that we have on Open RAN, ORAN, really, to date, there's 22 MNOs that have announced intentions to deploy Open RAN-based commercial networks. We will monitor how those go over the future here the next few months. One of our activities or functions is to look at the scalability as well as the deployment capabilities and any of the challenges related to ORAN deployments on this working group. Also, operators and integrators look to the cost savings here. So it'll be interesting to see what actually falls out in terms of cost savings on deployments, but the projections are anywhere from 35% to 49%, which is obviously a critical driver. The reductions are coming through open source software, hardware reference designs. It's also a native cloud infrastructure architecture, and it's got embedded intelligence throughout the network or throughout the RAN system. Also, there's improved network efficiency and performance through automation and some of the monitoring and real-time closed-loop control systems. Next. So one of the things that was announced within the past week, I'd say week and a half, is this Open RAN Policy Coalition. I'm going to just focus on the goals here, but this is an industry group, again, that's really looking to promote some of these policies that include support for global deployment and development of open interoperable wireless technologies, to signal the government support for open interoperable solutions, also look to the government for procurement to support vendor diversity within their ecosystem, fund research and development, and remove barriers to 5G deployments. and also to avoid any sort of heavy-handed regulations or prescriptive solutions. So this is an industry-driven viewpoint on how to drive Open RAN. Next. And by the way, there's about 33 members now. It says 32, but there's about 33, I think maybe 34 at this point. I didn't mention, but O-RAN Alliance has roughly 200 members within it from industry, which includes service providers as well as vendor community. This should really be titled O-RAN Summary. That's my bad. So the value proposition here, again, just in summary, reducing capital and OpEx costs, common vendor implementations across the open interfaces to add RAN programmability through open APIs, increasing deployment velocity, also to use RAN software-based environments and leverage open source software in that. O-RAN Alliance is now on their second version of open source software called Bronze. And that we're also going to take a deep dive in terms of the open source software usability in terms of O-RAN as we move forward. Some of the challenges, though, I mean, there's a lot of great positives that are mentioned, or discussed when you talk about O-RAN. There are some challenges in terms of the business case for opening the RAN while maintaining those KPIs that are critical. Also, opening and disaggregating radio communications is fairly complex. Integration and lifecycle management components from multiple vendors can be difficult. I think anybody knows this is a really exercise in a system integration, depending on how many different versions are open source or different part components of software vendors are involved. Open source software is not deployable out of the box to that point as well. There'll probably need to be some type of model to get a much tighter version of software for production running. And security aspects of disaggregated architecture, this can open up some security holes potentially when you have an open architecture. Next. So the other key component, we really broke the work group efforts into three functions, IoT being one of those. So we're starting to do a deep dive on the different vertical requirements. So far, we've spent a fair amount, I would say a good amount of time on industrial and some of the control systems and automation systems. We've had a couple SMEs, actually 3 different SMEs, speak to us on this topic and some of the requirements. One of those being Bosch, one from Cisco, and one was more from a vendor. I think Ericsson talked about this a bit. So these systems also have very tight latency, security, and on-prem requirements. In general view, the industrial is that IIoT needs private spectrum. That was presented by one of the members who also is, that was Bosch, who also runs the 5G ACIA group. OT/IT controls desired for support, security, to avoid interruptions and investment protection. Other verticals we're going to take a deep dive on will be healthcare, transportation, connected cities, enterprises, and if we have time, we may get into a couple others, such as agriculture. And the real view here is from a spectrum viewpoint, looking at both shared spectrum and what that opportunity provides from, whether it's industrial or some of these other opportunities like cities, concerns on interruptions, standalone network services. Also, worldwide industrial leading countries are starting to move towards private spectrum. I've got a map of that I'll show. And then what's best spectrum for private use is another question. And how does this differ from a service provider offering, or is service provider offering capable of providing this? But some of these initial deployments are in mid-band. There's also a second wave that's looking like it's growing to in millimeter wave, which may provide more reuse capabilities. Let's go to the next page. So this just shows a quick view of worldwide deployments to date. The US there in purple is really a shared spectrum opportunity, where the other colors are very much focused more on private, although some of them have some sharing as well. And you look at this really from the industrial vendors are the ones driving this. Industrial is the largest non-consumer vertical in IoT. And if you take a look at the revenue streams there, they're the ones that are really driving the need for some of the private spectrum in the various countries. So these countries are all that are highlighted are mainly the top 10 industrial countries. A few of the countries have adopted these private real estate-based licenses for local services. The initial spectrum availability or licenses are in the mid-band. I would say Germany is probably the furthest along. They've got licenses that are granted. People are starting to build out. And industrial has been one of the top applicants, as I mentioned. And they're also, as a licensee, responsible to comply with regulations in those countries. So there's various models, though, in terms of, who can bid, how the service can be offered, et cetera. And we'll be presenting some more of those details coming in the future. Next. So, Brian, I'm going to turn it back to you to talk about NextGen and 6G.
Okay, thanks, Russ. So if we can move forward to the next slide. So as we talked about last time, with 5G just getting deployed, there's already talk going on what the next generation is, 6G. And we have some research efforts that have begun underway through various regions of the world. We have some nation states that have, advocated that they're going to be leaders in 6G and are creating, some activities within their countries. Most recently there's the 6G Summit, which was held out of Finland, which turned to a virtual event, recently completed a look at what 6G is. And out of that, we've had some countries state that 6G may be as soon as 2028. With all this activity going on in the world, ATIS really took a look at what we need to do to promote U.S. leadership on the path to 6G technologies and, really developed a call to action. When we look at 6G, there's a number of areas that really could be of focus. Certainly AI and AI-enabled advanced networks and services are one area. Advanced antennas and radio systems, multi-access network services, and some of the verticals, especially in healthcare and agriculture. As Addis points out, we do need a national plan for technological excellence. That would include additional R&D funding focused on the core set of technological breakthrough areas that we can lead here in the U.S., tax credits to encourage massive investment in a core set of technologies to promote U.S. leadership, working with industry to develop a consumer and business-centric solutions to wireless spectrum challenges, and creating a national spectrum policy, as well as exploring innovative ways to promote widespread commercial adoption of U.S. developed and produced hardware and software, using things such as financial incentives to public and private sectors. The bottom line viewpoint is, 6G is happening around us. If we want to lead, now is the time to engage. This call to action paper that Addis has developed is certainly worth a read, and certainly points the finger at Addis for needing to engage within this 6G evolution. So with the next slide, I'll turn it back to Russ, and he'll bring us through the closing for our talk.
Sure. So in summary, some of our next steps across the entire working group, mid-band spectrum is a priority of the working group, IoT, potential for millimeter wave spectrum use, 6G spectrum planning should start now. We're going to dive a little deeper in terms of what recommendations could be there specifically in terms of the FCC. Spectrum use efficiency, this is a hot topic within our working group. We've had some spirited discussions over the last week or so in terms of efficiency, spectrum, and densification. O-RAN explores split options and vertical needs from a probably need-to-know basis or a good-to-know basis. O-RAN, another one on O-RAN evaluates the change in competition or in completion related to deployments. Also on security, although it's not specifically tied to the working group, jamming and spoofing In terms of both ORAN and some of the shared or licensed are topics we think are valuable for the FCC to be aware of. A deeper view on location and timing tied to 5G. We've had a couple presentations as well on GPS enhancements. The reason this is important, though, is location capability and timing capability, network timing and so forth, really is tied to location, which is a critical component of 5G for many use cases. And getting that for both automation and robotics is critical. Also, neutral host work tied to ORAN support. It's an emerging area. Coexistence between licensed and unlicensed. This is an area we have not done a decent amount of work yet within the working group, and we do need to liaise with the other working group, the unlicensed working group. Also, traffic offloading. What's the difference between 4G, 5G in terms of things like Wi-Fi offload capabilities or support, and what's required, and how that maybe even ties into MEC in terms of application support. And 5G resiliency is another topic that it has an important aspect to the three sliders we talked about. Next. So Dennis is always talking to us and sort of hammering on us in terms of actionable recommendations, because that is sort of what we are chartered with, and coming up with things that we should advise the FCC from the technical perspective. So the top potential areas, and there's probably no surprises here, licensed mid-band spectrum opportunities or shared, locally licensed spectrum for IoT verticals, possibly ORAN support related to promotion and of adoption and deployments, efficiency related to spectrum use, security related to spectrum jamming issues, on 6G spectrum planning and viewpoints, and last one, shared spectrum. This one's a little bit wordy compared to the other ones, but regulatory signal strength limits potentially reduce the efficiency of CBRS. And so a data-driven model limits could provide greater optimization than what's deployed today. So as we look at shared spectrum moving forward, we may want to look at more of a data-driven model in terms of what that really relates to is real time, as well as mapping information and so forth, and the actual environment to offer even greater license opportunities. And that's it. We're open to questions, input, and comments. You can go to the next slide. I think that says the end. Thank you.
So this is the time. I just sent a chat item for you. For some of you, you haven't quite figured out how chat works, but the instructions there, you slide your cursor and the little blue bubble will appear. You click that bubble and then start typing at the bottom with your questions. While people are formulating the question, I really want to compliment the group. There's so much that you have covered in this first half of the year. It's really quite an amazing presentation that we've just had, and the breadth of the coverage that you are providing, and the global nature of the coverage as well. It's disappointing, I guess, to all of us, the impact that the virus and all of the rest have made on the standards progress, but still things are moving forward. And as Brian said, 6G may well be here in as little as 7.5 years, so, or 8 years, depending on what time in 2028 that occurs. But it is coming, even as we are focused on 5G. 6G is coming, and I do hope that we will be more focused on that, as the government has become very focused on 5G, and we've really got to do a lot of work on 5G. In truth, a great deal of the 5G, particularly standards, but even implementation, the horse is a little bit out of the barn at this point. There are things to be done, but if we really want to be leaders, we need to be thinking about 6G, as the presentation has pointed out. All right, I am shocked that there are not a plethora of questions coming out. But okay, here's one. And Russ, maybe you can see one that just popped up. Well, here, Steve Lanning, and then from Shahid. So you want to pick those up straight off the?
Yeah, so I see Steve's first. Let me read his question. We had a contribution from the TAC Antenna Working Group that suggests far more spectrum reuse is possible. How does this factor into the needs for more spectrum in this report? So I think this is a great point, and this is why I said we've had some of this discussion within the working group in terms of looking at the need for either additional spectrum balanced with the opportunity for spectrum reuse. And it kind of ties into the next question as well, which I'll get to. But in terms of this is an area we need to take a deeper dive. And Steve, I think it would be great for you to present some of that material back to the working group this year for us to focus on in terms of what some of those reuse possibilities are. As we get into millimeter wave, because of propagation alone, there's a greater opportunity for spectrum reuse, clearly. And this is some of the discussions we've had related to sort of private spectrum, at least for in-building type spectrum. The reuse on high millimeter wave is very good. It's a little more difficult at the lower bands and mid bands because of the propagation characteristics. So I think this is a key topic for the group to focus on in terms of, it's almost like another slider on that equalizer, though, of how we drive some of the spectrum reuse. The next question, and I'll let Brian comment on the first one too, but let me cover the next one as well because it's somewhat related. Russ, can you talk a little bit more about data-driven models, CBRS, what can be improved on the SAS architecture in place right now? So the reason, and this goes back to the spectrum reuse question as well, Preston Marshall gave us a presentation. It was just a fabulous presentation. Preston's with Google, who's also one of the SAS vendors for CBRS. And what they sort of presented, there were a few slides towards the end where they started talking about this sort of what I call the data-driven model of being able to, because right now CBRS, a lot of it's done geographically, but if you actually take a data-driven model and map, like Google has mapping software as well, with buildings, even types of trees, and taking into account seasonability and what type of interference, there's an opportunity to potentially use that data to drive greater licenses because you will be able to, there will be less interference because of some of those factors, and factoring that in instead of just a raw sort of rule related to geographies and things like that. So there's an opportunity, I think, from a SAS vendor perspective, or is the next, maybe even a next gen SAS, to look at. Now these are all just open discussion here, right? But looking at that SAS to be able to do more of a sort of back off or balancing maybe between licenses and things so that you can squeeze more in. That's just one aspect. There's probably some experts on the group that could dive into that a little bit more, so I can open it up to others as well as to Brian to comment on those two questions.
Yeah, Russ. Nothing further, but on the first point from Steve Lanning, definitely want to hear more bringing that into back into the TAC working group so that we can explore that. But more spectrum obviously is the key, and whatever methods we have available, we should explore.
Ooh, there's a big question there. Any other comments from the team on that before we move forward to the next question? Any team members want to make a viewpoint? Okay, so the next question, natural market-driven adoption of standards and light touch mandates to industry.
Well, wait. I think you've jumped over. I think there's one for Brian on you've jumped two in fact.
I did. Sorry. Yes.
So, Brian, you have one that's up next. So as anticipated, you all were a little slow on the draw in getting your questions out there, but they are coming in a torrent as I anticipated they would. So Brian, why don't you take the one from Michael?
Okay, yeah. Can you elaborate a bit further on the 22 MNO announcement? Is there a particular network component MNOs are interested in, or is this an effort to showcase the O-RAN interface and specifications? Yeah, I think it's that. I think it's the fact that, you know, operators are interested in opening up the RAN for various reasons, and getting these 22 operators engaged within this activity, you know, certainly is an effort to help progress and showcase those efforts with those specifications. That answer?
Can I make one point
Sure.
to that? That the 22 MNO announcement is for Open RAN, by the way. It's not specifically O-RAN.
Yeah.
Yeah, I just wasn't sure if there's a specific component that's, you know, more important, critical to the MNOs than others as we go through this Open LAN or the O-LAN specifications.
I mean, I think this is about getting deployment to prove out the architecture, to prove out what's been done in the specs, and to, you know, these are first early deployments, and to look at, you know, also to get vendors lined up, and, you know, so this is sort of your first customership early proof of concept phase.
Right.
Yeah, Russ and Brian, if I could just chime in a little bit, it's Kevin. I think it's safe to say that the most maybe mature part of the O-RAN is the open front haul interface. So I think from a practical standpoint, that's a significant focus of deployments would be going on right now. As the specs, you know, it takes time for the specs and the implementations to mature. In all the disaggregating all the other pieces of the baseband processing, for instance.
Thank you.
Kevin's a key partner to us, by the way. He's one of the chairs of the most people know the RAN technology group. So, but he's also we participate in each other's working groups. So next question, while 5G and 6G are about wireless, how is the balance of network resource, such as depth of fiber coverage and infrastructure, such as computing, storage addressed on an even-handed basis? Getting bits off the air frees up spectrum. So I think this goes to the point of the network offload that takes place today. I mean, obviously, there's a tremendous amount of Wi-Fi offload that takes place on 4G. You know, that's one of the topics we defined is we're going to take a look if there's differences related to 5G. I mean, we're talking about a great deal of additional bandwidth as you saw the exabyte growth that was presented over the next few years as we get to 2025. But, you know, offload is going to be a critical part. I think how deep fiber goes, you know, clearly 5G is like, you know, to the cell tower, and you've got fiber backhaul to get to the different cloud and offices and so forth. You know, the other piece of that, we're starting to see more deployments of mobile edge compute that go along with 5G to support more real-time type decision making and vertical use case needs to reduce latency. So it's not just the offload from the bandwidth, but there's also latency, there's applications. And that's why I think 5G is a bit different than previous Gs, because we're talking about really the vertical support, the massive amount of data, the applications, and the virtualization that are all sort of coming together. And so it is a different game in that perspective. But it's a good question. These are all topics we'll be diving deeper into. I think that's from Adam, possibly. Does that answer your question?
Yeah. Yep.
Yeah, I think any service provider is going to want to be very efficient in terms of getting, quote, bits off the air to free up spectrum. Okay, so the next question, which I jumped to a little bit prematurely, natural market-driven adoption of standards and light touch mandates to industry compliance with particular standards historically worked well in the U.S. Additionally, Open RAN technologies are in relatively early stages of development, and the evolution to Open RAN architecture is different to greenfield operators from established networks. With that, is it too early to recommend policies and actions related to Open RAN technology? You know, I think this is a discussion we've had a bit on our team as well. This is a new area, but at the same point, it's emerging extremely fast. And there are both some challenges as well as opportunities that are emerging very quickly. So I think we're at a right time to be making some of the recommendations on policies and actions here. This is moving fairly quickly. And I think the different groups that have have come up, including ORAN Alliance and Open RAN Policy Coalition. I think the timing is actually very good. Brian, I don't know if you want to add to that, but I think this is the time as these things are, with the 22 Open RAN announcements, deployment announcements too. I think we're starting to see some of those deployments and some of the outcomes of those. So Brian, I'll let you turn it over to you.
No, I think Kerry makes a good point, that we're in the early stages of the development and evolution of these Open RAN architectures. But as you point out, it is evolving quickly. And with that, we need to be on top of any policies or actions related to it. And, as you mentioned, the creation of the Open RAN Policy, Coalition certainly reflects the fact that, there are policy-related issues that should be addressed. So it's a good topic, I think, that we'll need to address in the second half of the year and do deeper dives on. And I think we have on our target to bring in the Open RAN Policy Coalition as well to get some of their thoughts. So, yeah, good point, Kerry. Thanks.
So there's another question that popped up. Brian, you may want to take that one.
Yeah, I think these are, the 22 MMO announcements are they deployments or engagements, including proof of concepts. I think they're more towards the latter, the engagements, proof of concepts, etc., more towards the deployments.
Yeah, I may have overused that word deployment.
Yeah, as Jack
concept. Yep.
Yeah, and Jack emphasizes they are not deployments. Yeah, they're more toward the proof of concepts. They're really not deployments yet.
Any other questions? Are we on time, Michael? Do we have time for more?
You have successfully absorbed the earliness that we had established.
At least we don't have 143 slides to present. That scared me when I saw that number.
So I think it is time. I think it is time to transition. So we'll move to our other 5G group, if you will. It's a continuation of the same big topic for sure. And I'm not sure what Michael is doing with the slides in front of us here, but we'll get that momentarily. So in any event, Kevin and Tom, as soon as we get the slides organized, if you would take the baton from Russ and Brian, that would be terrific.
Sure. I'll kick it off. Just to reiterate to folks, this working group is focused only on the RAN, not on all of 5G, and particularly on the technology evolution aspects of the various parts of the RAN, and how it impacts the things that at the core of the FCC's mission, spectrum, interference management, and related topics. So today, of course, we're going to cover the preliminaries, just reiterate at a high level our charter and members, and Tom's going to go through a summary of the presenters that we've had so far, some in combination with the other 5G group, and we'll give a quick kind of update on the where we are in the work plan that we had outlined in the last meeting. Then we'll go in a little bit more about the all the components in the RAN and the insights we have so far from both the SME presentations and the discussions that we've had as a working group. So that will be kind of the meat of what we have so far. Not going to be putting forward recommendations quite yet. We're still fairly early in the process. And then we'll end with kind of a summary of the high priority areas that we'll be focusing on going, forward for the next, through the September meeting timeframe. So we're going to go on to the next slide. So our, as we've discussed before, is primarily technology oriented here as opposed to ecosystem oriented. So the way we think of this is that we really view it as looking at the technology evolution in each of the major component parts of the RAN, but also the RAN as an overall system, because it is a closely coupled overall system, and then how all of those the advances in those areas are interesting in and of themselves as a view of where things are headed and what the current state of the art is in those areas, but also really charged specifically to look at how those changing technologies, as well as different spectrum bands and things, how that impacts the challenges for doing spectrum management and interference management. So those are going to be very meaty parts of our workload, which we will be continuing to pivot towards as we sort of wrap up the early stages. You want to go to the next slide? We have quite a broad and talented membership, and quite active as well, of both members and designated SMEs. I would also say that our FCC staff, the liaisons and Monisha, in particular, have been very active in this work group, and bringing up lots of good questions and pointers of the areas that would be of most interest to the FCC, the areas that they're maybe most sort of interested or concerned about. And so we really appreciate the engagement of the FCC staff in this work group. If you want to go to the next slide. Tom, you want to cover a summary here?
Yes, thank you, Kevin. Appreciate that. And again, I wanted to echo Kevin's comments in terms of appreciation we have for all of the TAC working group members, their contributions, and that of their colleagues so far. So it's been great, and we look forward to continued contributions and great discussions going forward. So we'll just hit some of the highlights here, and Kevin's going to go into more detail in the subsequent slides. So if you could hold your questions on that. But here are some of the key guest speakers we've had in the working group since we kicked off around the March timeframe. So we had Greg Wright from Nokia, who kind of talked about the whole end-to-end RAN components and some of the flexibility, which areas are more flexible in terms of being able to virtualize, which areas are more challenging, and which areas are more straightforward. So we'll talk more about that in a few minutes. Rob Soni from Nokia also came in and talked to us specifically about virtualization and how that's going in Nokia, what some of the drivers are with regard to things other than TCO savings or total cost of ownership savings, and then also different types of vRANs and the pros and cons of those. We were privileged to have Boris Merman from Stanford University come in and talk to us and do a very deep technical dive on A to D converters. and talked about filtering and dynamic range, where we're seeing improved performance, but also considering some trade-offs with power consumption. So we'll hit some of the highlights on that. Subsequent to that, Diane Mukherjee from Intel came in and talked to us about their perspectives on virtualized RAN and the progress that's being made in real-time optimizations. Some of the considerations for once you virtualize, who becomes a system integrator and how you manage that. And then, did highlight some of the observations that have been made earlier by the 5G IoT group in terms of some of the greenfield deployments, for example, in Rakuten have claimed about a 30% TCO savings. So more to follow on that. John Smee from Qualcomm was able to join us, and we thank him for his presentation on the user device, or the UE, and what's happening in the technology there. The proliferation of bands, what's going on with the technology, and some of the subsystems be able to manage both the bands and the interference as we continue to evolve the UE. Maury Rumney, who came in to talk to us about massive MIMO on behalf of Keysight. He had presented, I think, last year to the antenna working group, so shared his views on massive MIMO, both beam steering and beam forwarding, and helping to distinguish between the two, and where he saw were the different opportunities across the different bands. We also hit on some of the challenges in measuring interference and total radiated power. And my screen just went black.
Yeah, mine is now. Yeah, apologies. Just got reset it, so give me 1 second.
Okay. Great. Okay. So that's just a summary of the highlights, and as I said, Kevin will go into more detail as we go step through some of the findings.
Okay. Yep, you might need to click once or twice to get the rest of the content of this slide on. But I'll just pick this up with, as we had presented last time, we had kind of a plan of attack for looking both across the areas, but in the specific topic areas we wanted to cover. So we really wanted to cover this whole space, but maybe not equally with prioritization. So what I would say is we're progressing very well in this upfront, intake of information, particularly in the highest priority areas of the RF and the baseband processing, but also in the UE area as well, thanks to John Smee from Qualcomm. And we'll be filling in other topic areas, such as front haul and in the RF space, each of the component spaces is kind of a specialization unto itself. So I think we will have more talks there, particularly probably in the antenna space and perhaps some of the other spaces as well. So we'll be filling in a little bit more of that intake, but increasingly, pivoting more to deliberations and discussions and analysis of what all that means from the standpoint of challenges and opportunities for spectrum management and interference management. If you want to progress to the next slide, you have to click a couple times. Forgot this slide had transitions in it. One more. Here we go.
There we go.
So, this is kind of a consolidation of what we showed before, so we could have all of this kind of on one page. But it illustrates the component parts of the RAN that our work group is focused on, looking at all these pieces. but particularly trying to discern the parts in here that are sort of gating advancement, gating progress in one way or the other. So, for instance, in the RF part of this, of course, you always want to increase the performance in many different dimensions. One aspect of it, of advancement in the RF part is, can you make the RF, flexible, sort of programmable in an SDR sort of sense. And so that's one aspect. That's sort of one lens that we've looked at the RF side from. But then you also need to advance, whether you can achieve flexibility or not. You need to advance in order to be able to handle the much greater spectrum bandwidth that you're covering, and the more advanced antennas and antenna arrays. So there's a lot of need for advancement in the RF part. And I would say that, what we'll talk about is the advancements in those areas are not necessarily equal. In the baseband processing part, more to the middle of the diagram, the processing part of this, the gating is a little bit different. These are all well implementable, but gating in terms of the challenges associated with virtualizing the various pieces. And so, not surprisingly, the lowest layer parts in the baseband processing, the PHY and to some degree the MAC layer, are because of the extremely tight latencies associated with very, very tight control loops, millisecond or even under millisecond, as we go forward, control loops. And the sensitivity to delay variation, that just makes putting things on general purpose computing quite challenging. And I would say that the state of the art is that you need some kind of hardware acceleration of one type or another in order to implement that. So virtualization of the RAN, a virtual RAN can be a relative term, where it is general purpose computing, but it may be general purpose computing with some either specialized FPGAs or GPUs or other methods assisting doing the hardest, heaviest lift in the RAN. So if you want to go to the next slide. So we also took some time to I got some things popping up on my screen here. Apologize. To clarify some things that there was, some confusion in the way terms were used, and it's important we're all using the terms the same way. And we've seen this confusion oftentimes in the industry as well. CRAN is a particularly onerous term because, is it Cloud RAN? Is it CRAN? Is it, there's a lot of different things that the C can stand for. So in any way, we're trying to use what I think is the industry standard terminology. So typically, DRAN and CRAN is the distinction between the distributed RAN and a centralized RAN, meaning some part of the baseband processing is central and not sitting at the individual cell sites. So it really refers to where those functions are located. And of course, with various split points, you can have part of them distributed and part of them centralized. But if any part of them is centralized, it's generally referred to as CRAN. Either of those, frankly, can be implemented in either a classical or virtualized form, although usually you think of virtualized forms as being associated with more centralized architectures rather than distributed ones, just because it's not always convenient to put general purpose computing infrastructure so far distributed to cell sites, but it's certainly technically feasible. The other point is that both DRAN and CRAN architectures are widely deployed together. More DRAN, of course, than CRAN because that's been the traditional architecture. Also important to note that, VRAN is not one thing. There are many variations of VRAN. One common terminology is, VRAN 1.0 refers to when you take the baseband processing, take the upper portions, and virtualize just those CU or centralized unit functions. That's referred to as VRAN 1.0. VRAN 2.0 refers to when you're virtualizing both the CU and DU parts of the baseband processing chain. And the lower layer parts in the DU, when you virtualize those, a lot of variations depending on what type of hardware acceleration that you're using. This is a very active area of both research and development. Is the best implementations for the DU. But in general, when people say can you scale virtual RAN? Can you implement functions? I think it's to a large extent it's a matter of can you? It's sort of trade-offs of and power, and how tightly can you regulate timing and delay variation and things like that. But in general, once you've implemented in one way or the other, you've still implemented the same functions. It's really an implementation choice of how you implement them. Obviously, any form of virtualized RAN is going to be easier to sort of break into pieces, whether that's for multi-vendor purposes or it's for allowing you to scale, let's say, control and user planes differently, or to scale different network slices. So VRAN provides a lot of flexibility in that regard. If you could go to the next slide. So at a kind of overall perspective, just to kind of set the stage, on the current state of the RF technology. So I'm going to go through RF and baseband processing and the interference topics, the ones that we've, sort of our leading topics. And we'll probably similarly report out on things like front haul and things at subsequent readouts. But at an overall level for the RF, it wouldn't be a surprise to most of you to say that the base station RF chain is extremely optimized, at a sort of a physics level. And there are a lot of trade-offs between the components that make the performance of the various components, the performance and cost trade-offs and space and power trade-offs, all those are all very sort of tightly coupled. So all of these pieces are very sort of tightly optimized together and have been a focus of optimization over, over quite a few decades at this point. It's sort of a very tight thing, and with very, very high tech, sort of optimization in there. If you break it down, though, and as I showed on the earlier the diagram, it's primarily the receive chain that's the more challenging and limiting than the transmit, as you might expect, because power levels and dynamic range required, things like that, are so much more stringent. Within that, the most critical components, or the gating components, to use the terminology from before, are really the filters, the A to D converters, and sort of indirectly the accuracy of the oscillators. I'm going to go through that, go into a little more depth in that in the next slide. I would say that from all the inputs we've had so far in discussion, the current advances in the RF, and there are a lot of advances going up, but they're more oriented to handling higher bandwidth than they are bringing, let me call it, flexibility or programmability to the RF. So as far as RF flexibility goes, this kind of, ideal of a software-defined radio that could be tuned to, different bands, could be kind of more universal. Maybe they could become multi-tenant, all these kinds of things. So that kind of tunability is really not yet on the horizon. That's, I don't think we found anyone who would say that that's going to be there in 6G, for instance. So we probably won't be focusing too much more of our effort on programmability of the RF, but rather on some of the other challenges of millimeter wave and massive MIMO and interference and measurement and things like that. If you want to go to the next slide, I'll go into a little bit more depth on the components. So the critical components, again, the kind of the filter or duplexer, whichever is used, the A to D converter and the oscillator. So the filters, this is an area that, because of pretty extreme rejection ratio requirements and the need, of course, for very low loss passing through the filter, very low loss in band and extreme rejection of out of band. It kind of limits the technology choices, not exclusively, but these are typically cavity filters, and they do represent a significant part of the volume and the weight of base stations. And volume and weight is important because that translates to loading on towers, visual, how they look visually, and then typically ultimately cost, right? So these are all things that you want to bring the size and volume of radios down, and so to some extent the filters are a sort of a gating item for advancing those aspects of the RAN. Because of that, sort of the advancements here, are a little bit more stagnant compared to some of the other areas, and it is definitely a barrier to kind of SDR type tunability. In the A to D converter, really the A to D converter and the oscillator spaces are closely related, because what the A to D converter can do depends significantly to the accuracy and the low jitter capability of the oscillator. So these two are quite coupled. We had a wonderful presentation from Professor Merman from Stanford, as Tom was highlighting. He's collected data over, 2 to 3 decades now, plotting the advancement of technologies for implementing particularly A to D converters. He also tracks the A converters, but the A to D converters are, again, the gating ones. So there's really a wealth of knowledge and insight in this area. And really what he's highlighted is that the A to D converters are advancing. They are advancing, but sort of unequally between the more low frequency applications and the higher frequency applications. So the lower frequency ones are really kind of starting to hit a real practical limit, where it's not that you couldn't drive them farther, but you wouldn't accept the cost and power penalties associated with it. The high frequency side, good thing, because we're implementing such much higher frequencies, are advancing at a higher clip. They're not up against the limit, but the higher frequency A to D converters are also less power efficient. So then you start bumping up against the sort of power trade-offs in that area. But that would be the area that in A to D converters that would be advancing the most and where the most focus would be right now, because of the wider spectrum being used in 5G, and the fact that it's not quite hitting the limits that were there before. But one topic, again, looking through that lens of tunability, that you could have a tunable radio if you were able to, instead of doing a physical filter, you could do digital filtering. and the A to D converter would be the primary place you would implement this digital filtering. But that would require much greater dynamic range. We don't have a physical filter in front. It would require much more dynamic range, and that much higher dynamic range, if and when it was possible, would require a lot more power, and it would require oscillators that are much more accurate, which would also require a lot more power for the oscillators. So again, with the depth of expertise that he was presenting, this kind of probably closes out our investigation on the likelihood of tunability in the RF. The power amplifier is less of a performance gating item, but we note it here because obviously it's a significant part of the contributor to the power used in base stations, and so therefore, the more efficient the power amplifier, then the more efficient the base station is going to be. So if you could go to the next slide. So shifting gears to the baseband processing and the vRAN topic. So vRAN, of course, is closely related with the progression of edge clouds and edge computing, and also because the expectation would be that the vRANs would be disaggregated and to some extent, and you would use that disaggregation for pooling or shifting resources for network slicing and things like that. End-to-end automation is also very closely related, and of course, vRAN and ORAN are quite closely related. I think the point that our speaker from Intel made was that, and I think they all quite agree with this, traditional vRAN architectures are going to coexist, and they're likely to coexist even in the same networks. And that there is this kind of progression when we talk about virtual RAN. And virtualized network functions in general. There's a progression from sort of dedicated hardware, bare metal, if you will, to being virtualized, then being cloud ready using containers, but really being cloud native where you're breaking things down into small chunks. So it's good to keep in mind that there's this progression over time. We're somewhere in that transition between VNFs and CNFs and in the industry as a whole. As I'd mentioned before, virtualization of the lower parts of the vRAN, of course, are especially challenging. It really requires hardware acceleration today. Maybe that won't always be the case, but it certainly is. We talked about Rob Tony talked about all the work going on at Bell Labs using GPUs for what he refers to as vRAN 3.0. It'll be on 2.0. And in general, the Intel speakers spoke about many areas that we're making progress on doing real-time optimization of kernel operations and pass-through modes and using SmartNICs and isolating real-time tasks and things like that. All that said, I think it's certainly true. We're not at the point where URLLC is being deployed yet, but given the latency requirements associated with that and the short bursts of the TTI across the radio interface, meeting the really stringent URLLC latency and jitter requirements will be considerably more challenging than doing just today's 5G with vRAN, or at least with virtualized DU functions. So when we talk about the benefits here, we kind of have a little bit of mixed inputs when it comes to what the cost savings are or not. We've heard in the Rakuten case what they found, what they claim anyway for a greenfield deployment TCO savings. Some of the other inputs we've gotten, I say particularly from the vendor side, looking at this, it's a little bit more of a mixed bag. It depends an awful lot on the specific operator, whether it's greenfield or not, fiber availability, their geographic density. There's a lot of factors that go into this. But I think where there is a general agreement is that the level of flexibility that vRAN brings and will become more important as network slicing becomes more of a reality in the network, is a major advantage of vRAN. And of course, what we expect is over time, Moore's law advances will make vRAN more and more practical for more applications. There are several variations of vRAN, which I'm not going to spend time going through, but on the next slide, just to make a few points, if you want to advance things. There are a lot of different variations, or I would say different deployment architectures, and these depend an awful lot on what's the best fit for the density of the area being served, fiber availability, and then of course what the application requirements are. You're going to distribute out the applications that need the low latency, but you're not going to put everything out at the edge. Where frankly it's more expensive to distribute the smaller, less economies of scale as you get to more and more distributed out. Very likely that all of these different variations, and there's more than what's shown here, would coexist in the even in the same network, because networks are quite diverse. So that's probably enough on that slide. I'm going to go to the next. So on the interference management front, which is of keen interest, of course, to this crowd, and particularly FCC, we're I would say early in our work in this space. We certainly are trying to pull out as many insights that relate to this as possible as we've gone so far. Far from having recommendations or strong conclusions, but some observations anyway here that certainly beam steering, beam forming are going to bring challenges to this area. The benefits, of course, is many new degrees of freedom to optimize RAN performance, maybe in under the right circumstances, substantially improve throughput through the RAN, but that comes at somewhat of a cost here. That much more dynamic distribution of power across the RAN, and the channel conditions more dynamic. Cell overlap areas are now maybe much more overlapping than before when you're beaming from kind of one cell area to another. And all of this is going to significantly complicate things like how you go about measuring radiated power and how you model in-band and out-of-band interference. So, a very rich topic, which we're going to be sinking our teeth into, but expect this is going to be a pretty lengthy and complex part of this work, Rick's work. But anyway, in any case, the discussions we've had so far really suggest that there will be need to be changes in how we measure RF power and interference levels and set interference levels, and that it may be quite complex, maybe quite a few trade-offs there. Another factor that's been brought up is the fact that a lot of these upper bands, middle upper bands, are TDD, and TDD introduces additional interference challenges. So primarily, these are areas that we'll be spending more time on in the next round here. You want to go to the next slide? This is kind of a visualization then of, as we step back and sort of assess what we've covered so far and where the priorities are. It's kind of a visualization of what the work group views as the priority areas, a little bit by size of the bubble, if you will. So a huge interest in massive MIMO, millimeter wave technologies, challenges, how that impacts things like the front haul and interference. And so that's a major area. vRAN continues as an important area. though we've done a fair amount of work in that area. So I think what you're going to see is those two areas and the interference management areas, things that probably dominate our time going forward. I'm going to go to the next slide. And I mean, to some extent, the visual sort of covers this, but we will be spending a lot more time on millimeter wave right up front. Some of the other technology areas that I would say, particularly, antennas, amplifiers, that we hadn't had any specific talks on. And then, of course, as I mentioned before, pivoting more to the interference management impacts of all these other areas that we had learned. So we'll be doing the usual things here. And that concludes our report for today. But let me just stop there and see if, Tom, anything you want to add that I might have missed or you want to emphasize?
Yeah, I just wanted to add on that we have a couple of speakers lined up for the next few weeks on millimeter wave deployment experiences and additional ones on massive MIMO. So we're continuing to get good input and information on that, and we'll continue to solicit the working group to continue to get additional presentations, information, and discussion on these topics. So appreciate it. Thank you, Kevin.
Okay, with that, I guess we'll open it up for questions. Maybe there already are.
There you go.
So let's see, from Lynn, you mentioned the challenges or barriers for RF critical components. Which of these barriers reduce the ability for carriers to share RAN on a single site for rural areas? Do you see these being solved in the future to bring vRAN on a shared carrier level? That's a good question. I don't think the technical barriers in the RF part are a barrier to RAN sharing, because you're in RAN sharing, you're going to typically take a block of spectrum, and then you're going to find some way to equitably allow multiple operators to use that. Now, RAN sharing is used pretty widely in certain parts of the world for particularly lower density areas, of course. It has not been as popular in the U.S. Maybe it's because our operators are very competitive in the U.S. There are some examples of third-party carriers that there's kind of as neutral hosts, but we haven't seen RAN sharing on a large scale in the U.S. That's not to say that there wouldn't be going forward, but I don't think the RF component barriers are a barrier to that. And in fact, in 5G, with all the network slicing capabilities, and particularly as those work their way down, today primarily on the core, and that gives you a lot of options to operate your own network. But then there may well be resource sharing down in the RF, or pooling and resource sharing in the RAN part. And when you get to that space, then it might indeed be possible to split RF resources, in a common band across multiple operators and give them policy controls like that. Okay. Next question from Kari. It seems that in Open RAN architecture, radios are becoming a commodity. Other vendors seem to develop their radios, and the focus is on virtualization and baseband processing on hardware. You highlight some critical aspects of RF development, such as filters and PAs. Is there a risk that Open RAN architecture will result in some suboptimal RF performance due to the commoditization of RF units. Yeah, in the talk that Rob Sony gave to us, he spoke to this a bit, and he said it really is very band dependent, and so therefore, when you're talking about sub 3 gigahertz low band coverage type networks, or macro networks in general, then that it's kind of less of a problem. I guess those are somewhat more mature areas, and so a little bit more mix and match there is much more feasible. There can be some sub-optimization, but the bigger concern is in the mid-band. You may be using millimeter massive MIMO, and in the high bands you're doing millimeter wave. There's a lot of optimization and a lot of new, because these are fairly new things, new optimizations going on there, where the RU, or if you will, the RF and the DU parts have to be kind of closely optimized. And in fact, from a throughput standpoint, typically the millimeter wave stuff is deployed in what's referred to as a RAP, a radio access point architecture, which just means that the RF and the DU are packaged essentially together, because otherwise you have a very large front haul capacity hit. So so in those areas, yeah, there's definitely the possibility that you end up with suboptimal or sort of impractical solutions depending upon the band. Let's see. So the next one from Peter, on the gap in A to D technology at higher frequencies, do you have a feel for the relative technology challenge versus an investment gap? Is it a matter of focus or market pull, true tech gap, or both? From both Greg Wright's presentation and Professor Berman's presentation, I mean, I think the sense is that these are areas have been traditionally intense focus of R&D and research. So I don't really think that it's an investment gap. I mean, people are pushing the limits of physics in these areas, and are quite motivated to do so. That's even true in the filter area, despite the lack of market. So I think it's more of a true technology. From Adam, I believe, more focused on the future. Where do you see competitive schemes where propagation between the UE and the base station is part of optimizing the RAN? Well, I'm not an expert in that area, but I mean, my impression is there already is quite a bit of operation going on. You need to do that in order to do channel estimation, for massive MIMO, for instance. Of course, that's relatively new, but I think that's very much on the table to include the UE. The UE really is part of the front end. The UE is really part of the RAN, and I don't know. There may be others who are more expert on that topic. Happy to have anyone else chop in.
This is Tom. There's some other features that are being, that have been standardized and are being developed, like coordinated multi-point and stuff like that, that are part of the standard and continue to evolve. So we haven't looked at that in our group specifically that much yet, but if there's interest, we can highlight some of that and have some presenters come in and talk about that. But there's definitely different aspects of cooperative work between the UE and the base station as the technology is evolving. So there's a lot of stuff going on there.
So Michael, just for those posing the questions, if you have a follow-up, do feel free to interject it. We're kind of reading and responding, but if there's follow-up or clarification that the questioners would like to provide, do feel free to do that. Okay, Edward.
Michael's question is, given the end-to-end DRAN architecture diagram, where do you expect a new entrant to start showing up? The RU, the front hall, the DU-CU? Yeah, I mean, if I look at those areas, take them one at a time. I mean, the RU part, there are a number of vendors doing, video parts, kind of a traditional set, I guess. I don't expect necessarily a lot of new entrants in the area. There certainly could be. In front hall is a transport function, and there are a lot of transport type vendors in the industry. So I don't know that there's a big opportunity for a lot of new entrants in the front hall space. Though again, it's possible given that we've got eCPRI front hall now, which is a new thing. But I think what you'll find is the traditional providers of transport will be will be enhancing their products to support eCPRI. I think most of the new entrants we think about are going to be more in the DU-CU space because this is primarily if you can enter with a relatively small team and do software components, maybe just certain parts. You can kind of cherry pick a bit and pick the parts that you think you can implement some innovative idea with a small team and then sell it at a low price. I think that's where and not to say that there'll only be components. There are vendors in the space that will do all the baseband processing parts together. But new entrants that haven't been around for a while may well be kind of cherry picking, or they may be looking at the ORAN architecture and saying, well, I'm gonna do some of these X apps that are part of the radio intelligent controller architecture, and I'm going to go in and I'm going to try and come up with just an optimization that works. Of course, all the other pieces of the ORAN need to be well defined in order for all that to work, but that's an area where a small player can come in and innovate by doing an optimization that works with other people's components. If we've exhausted,
we seem to have exhausted the questions. Another great presentation, and really a very hot area, and illuminating a lot of the things, both positive and not so positive. There was some hope, I think, that with some of the technologies, filters, and A to D, that there were some breakthroughs on the horizon, and I think the explorations say that that's not likely to happen, but there are still potentials there. But this is an important area. The point that Kerry made is the commoditization side of it. It's sort of it is and it isn't. The architecture is certainly not commoditized in that things are changing pretty radically in this area, and that's been highlighted by the presentation. And then the heat map here at the end, there's still a lot to be investigated, particularly of interest, the massive MIMO with millimeter wave and how those play together, and how filters and antennas and amplifiers and all the rest fit into that new paradigm of approach. So that's going to be a very interesting part of how the second half of the year you come out with your conclusions and directions on that space, given that there's so much spectrum up there in the millimeter wave space.
We don't really believe the two of them to play together. We really view them as two separate topics. I haven't heard anyone really believe that you're going to do massive MIMO on millimeter wave any time in the near future. But yeah, the other point I was going to make is there is sort of maybe a plus side. Maybe the ideal of a software-defined radio is not with us and it's not on the horizon. But when it is there, it's going to be another challenge for interference management. So the silver lining is you don't have to worry about that quite yet. Yeah,
no, even what you've just said, a lot of people historically talked about massive MIMO and millimeter wave as going to be the ideal solution. So even the point that you've made that that isn't happening is an important thing to get out and to make visible to the less informed. So
beam steering versus beam forming. Yeah.
Okay, so we are actually approximately on time. So let's. Michael has sent me a note here. Okay, yeah, it's just a suggestion for how to operate more efficiently. And what he suggested is that let the person who has the question read off the question and may want to amplify. This was a little bit what I was interjecting with the questioner's engagement with the question and answer forum. So we'll maybe make that small adjustment for the afternoon. But with that, we're again roughly on time. I think this time we will give you what's now 55 minutes. I know last time I cut it a little short, and some people had scheduled meetings during the 1 hour break. So we'll allow for people who have meetings scheduled during this time to conduct those meetings. But we will begin again promptly at 1 p.m. and future of unlicensed operations will be up first, and then artificial intelligence is the grand finale at the end. So that's where we are going, and have a very, very good lunch, and we'll talk to you all at 1 o'clock.
Sounds good. Thanks.
Actually, maybe I'll add one more thing. To be honest, this is the most painful part of the virtual meetings. I always look forward to the interactions around the lunch break and even before the meetings, the informal interactions, and that's the one thing we all really miss with this format. So I will just posit that point that I am missing being with you all, but this is what we have available, and it operates very efficiently, if not providing the byproduct of the human interaction and catching up with one another. So we have to figure out how to do that. One element of virtualness that is just not there yet. Something for us to advance the cause on. In any event, enjoy your lunch.
And what time should we expect the Potbelly's deliveries?
Slide, we will begin. I would note that we're on slide 62 of 143, so we are still not at the halfway mark of the slides. I think we really did have quite a feast this morning in the intellectual sense. A lot of really, really great information conveyed. Some of you in your chat items are noting that your meal was not quite of the same character. I don't know what happened to the drones, Michael, but I didn't get my potbelly either. But I think it was a productive time for people, and hopefully you were able to accomplish the things that you needed to get done through that time. But now it's time to jump back in, and we begin the dreaded after lunch time. David Young wears the cookies. We have the after lunch time slot, but in this case, we have a really exciting presentation on the future of unlicensed operations. So I trust everyone will be at rapt attention. So with that, Kevin and Brian, please take over.
Thank you. So it's to me, I believe. Can you hear me? This is Brian.
Hear you fine.
I can hear you.
All right, very good. So we'll kick off our after lunch session on unlicensed that Kevin and I chair. We're looking at future of unlicensed operations. So you can go to the next slide, please. And here's our list of FCC liaisons. We've got a great group that's helped us out, both on the technical side, and we're lucky to have an economist too. So there's some complicated questions we're dealing with, and we're happy to have the FCC liaisons helping. On the right side, you see our working group members, smaller group. I think we have one other who's joined recently that we will add to the list next go around. But some of these are, are our regular TAC members, and then some are subject matter experts from the companies that are helping us out. Next slide. Okay, so our agenda for today will, of course, look at our charter and frame things up really in terms of the questions we were presented. So that'll drive our presentation. There is, of course, prior work in the sense of prior TAC work and long history of unlicensed operation. So we want to look at that. We'll look at the value and what kind of progress we've made on unlicensed. Just understanding that shapes how we move forward, knowing what's succeeded and what's maybe not succeeded so well in the past. Like everyone else, we've had some really excellent speakers, subject matter experts that have come in. We'll take a quick look at those in the same format, and then kind of walk through really the questions and mapping some of the presentations and what we've learned from people onto those questions, and then finally kind of look ahead. We don't not spoil things, but not surprisingly, we don't have any actual recommendations yet, but we have some areas that are starting to take shape that we think are fruitful to explore. Next slide. Okay, so paraphrasing our questions, here's how we grouped them and summarized them a bit. First one has to do with how unlicensed complements or competes with licensed, and so this is an interesting question because I think your gut probably tells you it's both, and I think you're right. We'll look at this in a little bit more detail, and then that means it's less obvious how you continue to strike an excellent balance between the two. And as we search for more spectrum, more sharing opportunities, it just the topics get a little bit more complicated, but we think there's room to grow. A second question is about improving the user experience, and we think about that generally as what kind of new use cases, what are we doing with unlicensed to make the experience better for consumers, and therefore going with that typically is also make it more competitive. And this, as a result, it relates to our third question, which is the new services and novel applications. These all go hand in hand. I think we concluded everybody is trying to improve the user experience in their own way. So whether it's, for example, Wi-Fi Alliance, you can argue that what they're about is making the use of Wi-Fi better, and people deep in the weeds doing protocol development are doing the same thing. And then within three, there's kind of there's two parts to this. One being, what's happening in the technology development side, and are there regulations standing in the way of the development and better, more competitive use of unlicensed spectrum? Then finally, we were specifically charged with investigating sharing and taking a little look at personal radar specifically, but sharing is coming up repeatedly in our discussions and from our subject matter experts as these either within bands or as we try to get new unlicensed bands that might be shared with other users. Next slide. So as I mentioned, we have some we call potential findings here, kind of themes that have shown up, some of which I think have recurred, like the first one that as we've looked at this, we looked at this in the past, and so that'll come up here in a moment, but we always come back, it seems, to the view that light touch regulation and letting the industry drive some of the innovation in the standards and the actual technology seems to be the best approach. After we've had speakers to the second bullet here, one thing that's come up is there's kind of two ends of, if you would, the density spectrum, the user density spectrum. So where the notion of needing a high degree of coordination or sharing came up, it actually came up in our discussion in WISP for rural settings, where the issue of low density users and needing low capital and possibly wanting to share hardware or spectrum. And then at the other extremes, really dense environments where you have similar reasons, a lot of people packed in, potentially like in a venue, it may be temporary, but really high density applications also drive the need for a lot of coordination and sharing. Third point is what we see. I think this is a little bit of a no system as an island anymore kind of theme that's occurred. We see the people are in this business of implementing both licensed and unlicensed, and the people developing protocols, that there's a lot more attention paid to environments where things are shared, where you might have a lot of access points, you might be sharing between dissimilar systems, and we think that's not going away. So that's a good thing that that's happening, and it needs to be incentivized probably in the long term where it's not. And then most recently, we have, the notion has come up, and I guess this also tends to become an age-old thing, that the better you understand what's actually going on, the better off you can solve the problem. So somebody did raise the point of, do we really have a good handle on utilization of bands, interference, what's going on the ground. So I think we have at least one speaker coming up in this area, and we do want to spend more time on this topic. Next slide. Okay, this is one Dennis kind of teased earlier in the discussion. So we did, of course, go back and take a look. In 2015, there was a working group that did explore this area. I won't hit all these points, but the second row here highlights their recommendations. And we would note there's been quite a bit of progress on these recommendations. And so I feel like we're standing on the shoulders of giants, if you will, to be able to continue that work, look at new bands perhaps, and a few issues that have cropped up since then. But sharing's not new for our working group, but we do have more experience and some companies that are very deeply involved in it now. Next slide, please. Okay, also looking back, we did want to understand kind of where we came from. So that helps maybe shape where we're going. So many of you, if you've been in this business for a really long time, are familiar with all the way back to even sub 100 megahertz unlicensed operations, analog, other things that were going on back then. And it hasn't been a straight progression down the frequency chart, or up in frequency, because you can see we jumped in, did 60 gigahertz, and then we've gone back in to search for new spectrum and release additional spectrum along the way. But what what at least my takeaway is that there has been pretty successful use of unlicensed, in particular when the FCC is ahead of both the demand and perhaps even the technology. So I'm sure, like in '85, we could not do full-blown all CMOS. At least my memory is we couldn't do cheap 5 gigahertz all CMOS systems, and we got there. And I'm sure we couldn't do 60 gigahertz as easily in 2001 as we can today. So we get there, and it's what tends to work is find the spectrum ahead of the obvious demand, and then perhaps adjust as we learn, which we see some tweaks along the way to either make better utilization of spectrum or free up additional spectrum. Next slide. Okay, quick look using pretty much the same format many others do of who our subject matter experts in their companies are. So just briefly, Alex from Qualcomm gave us a good talk. It was pretty specific on access, on the protocol approach of using synchronous contention rather than I guess maybe what we might be more used to with the traditional Wi-Fi medium access approaches, in the interest of better efficiency. And CJ, we've presented and talked a little bit about some of our past analysis of unlicensed bands and then the recommendations. Peter from Cisco gave a great review of standards work and including some of the use and problems in, for example, unibands. Wi-Fi 6 explain what's going on or what has happened in the Wi-Fi 6 standard. That's the most recent 6 and 6E. We'll look at that a little bit soon, or here in a minute. Derek Peterson, CTO from Boingo, talked about their business model, which was, I think, educational for many of us to see a company that's, their whole business is about the complexity of sharing and deployment in various environments. Next slide, Michael. Then Ericsson graciously found us a speaker, Dr. Hertz, from who is deeply involved in the FCTC brand. So that was instructive to get a non-US, non-Wi-Fi, non-802.11 kind of view of how unlicensed becomes standardized and then finds its way into the regulatory environment. We'll speak to that in just a minute. We zoomed out to the rural environment and looked at how WISPs make use of unlicensed spectrum. That was Claude from WISPA, and then Kurt from Federated Wireless talked to us about sharing technology generally, CBRS and SAS. So that too was very instructive for us. Next slide. So we'll kind of step through some of our questions and see what we learned in some of these areas. The first one's about competing, complementing. Next slide, please. Okay, so I mentioned that you probably have this sense that licensed and unlicensed both competes and and complement. So we learned that asserting the economic value of unlicensed has its pitfalls, because as soon as you make some claims, there are others who might challenge, particularly if you position it as if unlicensed has this value, then licensed is somehow less. They're just different. So we know they compete. And part of the way we know they compete, of course, is by some of the dynamics we see in the market. So what we put here, we did want to cite that there are sources. There are Wi-Fi Alliance has its statements on the value of Wi-Fi. CTA actually published I think it came out in 15, but 2014 we did an economic impact, mostly looking at the hardware sales in the U.S. for unlicensed devices. And Wi-Fi Forward has done some economic analysis more recently, including looking at 6 gigahertz. The takeaway really to me is that there's evidence of strong demand. So the fact that FCC has taken action to open up unlicensed spectrum is justified in the economic value we have seen brought to the market. And as I mentioned previously, we still have this competitive issue that makes the sharing some other questions complicated, but I guess that's what makes our jobs interesting. Next slide. So this is a slide that Boingo used. I think it's just reflective of one company's take on spectrum. So we've seen a lot of spectrum deployed in both licensed and unlicensed, made available. And there's different views from at least one company on its utility and maybe various disadvantages. So, certainly in lower frequencies, 900 megahertz, which has been used for things like meter reading and other stuff. I mean, it just obviously doesn't have lots of bandwidth available, but it's been around, been used for a long time. Then 2.4 and 5 are really highly utilized, which is why there's been pressure to go back in and find shared spectrum and other candidates in these mid bands. We haven't really, we'll speak about this in a minute, we haven't really dug into 60 gigahertz yet. We got a speaker coming up that'll do that. Obviously bandwidths are, you got large channel bandwidth, but it's got its own propagation, interesting propagation characteristics. So, and I think, so this does reference, I just want to point out one other thing, this does reference, of course, the 6 gigahertz band. Ron mentioned that at the start of our call, so I think that's been an excellent, from our perspective, CTA's perspective, has been an excellent addition and a necessary addition to round out some of this mid-band demand. So I think that's it, and I will hand over. We can go to the next slide, and then Kevin's going to walk us through some of these topics.
So thanks, Brian. So in response to the question of how licensed and unlicensed can complement each other, we saw two great presentations on two different business models, one addressing low density areas and the other addressing very high density areas. So low density is the WISPs, and as Brian said, we heard from Claude Aiken, the CEO of WISPA. And I think most of you are familiar with the WISP business model, the wireless ISP business model. But these guys are very opportunistic, and they're very capital efficient, and they cobble together licensed backhaul with unlicensed access networks. So they often employ multiple wireless technologies, and they tailor their use of those technologies to the geography that they're in. They use a variety of licensed backhauls, legacy 3.5, 5 gigahertz. They sublicense 2.5 from Sprint. And then in the access network, they use the Wi-Fi spectrum 2.5 and again, legacy 3.5. As Claude said, they're 6 times as cost effective as fiber. By relying on these unlicensed bands, they're able to offer a good broadband experience in very low density rural towns where other ISPs just can't reach. So it's a great example of the utility that unlicensed spectrum can have for the country. And they're now looking at using the newly opened up 6 gigahertz capacity when it becomes cost effective to do so. Next slide, please. The WISPs are growing well. Today they have about 6.5 million customers, and they're estimated to have about 8.1 million by the end of next year. They're very capital efficient, they're very capital conscious, and so they try very hard not to spend a lot of capital on spectrum licenses, but rely as heavily as possible on unlicensed. And it's great to see the progress that they're making in serving rural America. Next slide, please. So at the other end of the continuum is the high density areas that Brian was referring to. And here we saw a presentation from Derek Peterson, the CEO of Boingo, and he was talking about distributed antenna systems being employed in places like sports arenas or military bases or high-density MDUs, multifamily dwellings. And I think most of you are familiar with this neutral hosting model. It's been around for a long time, but it's a great example of how unlicensed can be used. So the ISPs or the MNOs and ISPs content is aggregated at a single point and distributed within the high density environment by the neutral host. Next slide, please. So on the right here, you can see what the neutral host is doing. It's taking the service provider's managed networks and it's putting that traffic through a centrally managed operation and is using unlicensed spectrum within the neutral host environment. So they're heavily dependent on unlicensed capacity. Today they use mostly Wi-Fi, but they're going to be moving to CBRS and eventually 6 gigahertz as well. There are lots of players in this business model. Some of them are like Boingo or Newbridge, but also AT&T has a neutral hosting business, and in some cases, the venue owner themselves buy or contracts for a setup of the neutral hosting environment and manages it themselves. It's a challenging business model because of the relationships mostly between the neutral hosts and the MNOs or the ISPs. But as the neutral host can provide a more reliable service, sign on to better SLAs, the model improves. Next slide. So our next question is around how the user experience can be improved. And as Brian said, just about every presentation we've seen has focused on improving the user experience. That's what we're trying to do here. Oh, I'm sorry, did I skip a slide? Excuse me, I'm sorry. Where am I?
Yeah, 18.
18, sorry.
Yep.
So if you take a step back and think about what it takes to improve the user experience, it's really about having a very, very reliable broadband experience. Does the broadband infrastructure support greater throughput, faster speeds, lower latency? And so Wi-Fi 6, even though it's not spectrum, it's a standard, is responsive to the question of how are we improving the user experience. Wi-Fi 6 uses the same Wi-Fi 5 bands, 2, 4, and 5, but gets 4x the throughput of Wi-Fi 5 and a 75% reduction in latency. If you're targeting indoor operations, you can better serve corporate offices or dense residential MDUs. If you're targeting outdoor environments, you have better hotspots for stadiums or high traffic hubs. The APs use considerably less power, even though they have 4x the throughput. The base stations also have better power efficiency. The system is backward compatible to previous .11 Max and PHYs, and as we move on to 6E, we'll see even greater performance with 6 gigahertz. Next, please. So we'll have more of a focus on the user experience and emerging use cases in our next reports. We just had a great presentation on Monday from Broadcom. I won't try to summarize it here, but they identified a lot of new consumer services that will rely on unlicensed. And so we'll continue to focus on that for our future reports. Next, please. So question 3 is, what are the new services, protocols, and regulations that will promote unlicensed? And I'll throw this back to Brian for a minute.
All right, thanks, Kevin. Yes, I think, as I mentioned previously, this is like a technical drill down of the same issue of what's happening to improve experience. So standards work is driven by use cases. So if we, thanks. So one of the things we did, we wanted to get a different perspective on the standards and regulatory approach. And so Dr. Hertz from Ericsson did give us a great talk on this. We have a snapshot of one of his slides here. You can kind of discern how the process works, but the important things to understand is that the process couples together the standards development, something we think of as industry driven, so it is there also, but it couples that with EC regulation. The result that they're after is that it's highly specified, including the test requirements. And then from that, what they're allowed to do is manufacturers can self-test their products for compliance. So that is the effect, to be able to, when you're done and you want to use the CE mark, you can test. It is highly specified and regulated. The downside is that this development cycle is much longer, and the regulations are much more specific for these testability reasons. So as we looked at that, the conclusion was still, and I've mentioned this, I've probably hit this point 3 times now, the approach of a lighter touch on the regulatory side, and given some freedom for the industry to innovate either in standards or directly in the marketplace, or some combination of those, still seems to be the best way to optimize the market while keeping interference limited. Next slide. And so speaking of that, the FCC side of this, we have a well understood device authorization process. There's a couple of paths you can go through for the most part. What we're talking about with these devices, there's product has to be certified. So other than some tweaks around the edges, I think that the industry understands this well. Devices are certainly a lot more complex now. If you look at handsets, they end up in labs because they are a complex combination of radios. We've not tackled this issue, but it's the same thing that came up I can't remember if it was in Kevin's maybe, but this notion of more complex radios with beamforming and other capabilities makes testing more challenging, and that applies all the way down to the small devices we carry. Next slide. So we've been in the process. We're partway through getting a good handle on where standards are with respect to unlicensed bands and kind of marketplace introductions. So Wi-Fi Alliance did talk to us about Wi-Fi 6, which maps to 802.11ax. That's the part we have covered here. We have a good understanding of what's been accommodated there. If you look at the technology advances, you'll see many familiar terms. So one of the takeaways for us, I think, is that we see a lot of technology sharing between venues that work primarily on unlicensed and venues that work on licensed. So you'll see things like multi-user MIMO, beamforming, transient beamforming, how we handle constellations, this notion of driving down power consumption while improving throughput and other parameters, latency. The thing we have not gotten to yet, there is work, 5G in our unlicensed, so we have a talk lined up to cover that, to look at what 3GPP is doing and with unlicensed bands, and also 802.11ay, which is the 60 gigahertz. We're gonna look at it too. Next slide. Kevin, I think you're picking back up here.
Yeah, I'll pick up on the last one here for the last couple slides. What are the sharing technologies that enable what sharing technologies enable use with personal radar and additional spectrum bands? We haven't gotten to the personal radar issue yet, but let us talk a little bit about sharing technologies. We had two great presentations, one from Federated and one from Qualcomm, that came at the sharing issue from different perspectives. So Kurt Schabach, the CTO of Federated, which is one of the SAS vendors, talked about their version of dynamic spectrum access. And DSA is a software-based approach for allocating spectrum rights on a dynamic basis. And there are several approaches for implementing DSA, which can vary based on requirements, outcomes, and incumbents. And he described the access approaches as in three buckets: geolocation, portal notification, and spectrum sensing. And the geolocation requires the devices to basically use GPS to signal where they are, to make sure that they're using the spectrum fairly. Portal notification requires incumbents and new users to identify on a website someplace how they're going to use the spectrum, when and where. And then spectrum sensing is probably the most complicated of the ideas, because it requires the devices to constantly be, or the APs to be checking on the way the spectrum is used in real time and backing off when the incumbent needs to use the spectrum. It's a complicated system. The combination of those three things is in CBRS now, and it'll be very interesting to see how it works in the marketplace. We're also going to be hearing from Google shortly. They're also one of the SAS vendors, and we'll get a lot smarter about how this works. The benefits are obvious. It allows much greater spectral efficiency by allowing new commercial users to use existing bands. It can increase competition and create a secondary or a micro licensing marketplace, but it also protects incumbents. So this is something we're going to be spending a lot more time on for the rest of the year to see whether this can all work in the wild as well as it does in the laboratory. And Federated's position, not surprisingly, is that this kind of sharing technology should be used for additional bands once it's proven in CBRS. Sort of on the flip side of sharing, next slide, please, we heard from Qualcomm, which talks about synchronous access as an alternative or a complementary technology to other sharing schemes. And I won't pretend to be able to explain the physics. It's on the left side of this diagram, but Qualcomm's position is that much greater efficiency can be derived from a band without the complexity of a SAS-like system. It's a lower cost, more straightforward way of sharing spectrum. It's an interesting issue in light of what we heard from Derek Peterson at Boingo. Derek was saying that in theory, 3GPP and IEEE are supposed to coexist, but in his experience in his venues, Wi-Fi and LAA don't work together the way they're supposed to. And the Wi-Fi steps all over LAA, and that coexistence in practice is not as effective as he was hoping it would be. So the question is whether this technology also can be as effective as it's billed to be. So synchronization is one of several sharing proposals that we will continue to investigate for the remainder of the year. Next slide, please, last slide. So our next steps are to take a deeper dive into the standards. We have some speakers already lined up to talk about 5G new radio. As Brian said, .11ai and .11be. And then we've got a number of other great speakers. Microsoft's going to talk to us about white spaces. Google will talk about their version of SAS. As I said, Broadcom already spoke. Cable Labs is going to talk about 10G wireless and how the cable infrastructure can support wireless deployments. And then we also have Facebook lined up. So we're very interested in understanding sharing technologies better, looking at new use cases, and finally, as Brian said, we're going to be investigating opportunities to improve metrics and interference analysis, which is necessary to make the sharing technologies effective. With that, we'll thank you and open it up to questions.
Okay, the after lunch presentation time is completed, and it is time to get your energized questions in to the team here. Obviously not seeing a lot of questions. It is interesting with all of the speakers that you've had and going through this, many of them, appropriately so, are focused on the unlicensed side. I know some of the members of the team are on the carrier side, but how do you see that you will be able to secure the balance on the question of support or compete through the process that you're undertaking?
You mean get more input from the carriers, the licensees?
Yeah, a much more succinct way of saying it, yeah. Because obviously we have carriers on your team, so that'll be one of the mechanisms for getting it. But given that opening question was how compete or support one another, and you've talked to it, but the speakers seem to be predominantly the unlicensed speakers, at least from what I've seen.
Yes, that's a good observation. Brian, you have any thoughts on that?
Yeah, so I'd say, part of what happens, and we tried to dance around a little bit, even in talking about something like the synchronous access, is when something's presented, we will get either private or public during the meeting feedback. So we danced around and in the economic question too. So it's there. We know it's always there. And I guess the other evidence is that well, let me just wrap that point up. There's enough people from both industries involved to keep us honest. I think the other thing we're seeing is, and partly because the questions were teed up this way, but we can't just stay in our lane, just like we're not completely out of the lane of the RAN IoT, Russ's and Brian's group, because he's
Right.
sharing questions and the interaction of unlicensed and licensed together. We just can't untangle them anymore. So it's there.
Yeah. So, Brian, if I could ask a question instead of typing it in.
Well, first, actually, you're going to have to wait one, because Marvin did type his in, so he
sorry. Yep.
Okay. And that may give you time to type it in. So, Marvin, please, if you'd like to pose your question.
Yeah, I heard you say that Boingo reports that Wi-Fi and license-assisted access do not work well together, and this despite all kinds of FCC-mediated negotiations and testing and so on. What does that say about the processes that the FCC is using, or the rules that they've developed that need to be changed so that we don't have this problem?
So Kevin, I'll take a crack. That was your section. I'll take a crack
No, go ahead.
and then pass to you. So I think there was no suggestion it was an indictment of the process and the FCC involvement. So Derek was not saying, the government should have come in and made sure the outcome was different. It was just an observation, and not that they don't coexist, but just that his experiential outcome is that Wi-Fi, that LAA backs off to Wi-Fi more. I think that's the way he put it, or something like that, right, Kevin? So
yeah, that's right.
Yeah, not broken. He's just saying in this environment where we have both. If you remember, Marvin, back when this was first cropping up, there was sort of a sky is falling kind of reaction, maybe from some parties, and it got sorted out. So maybe the knob needs to be adjusted some, but it was just an observation of his real world experience. So there was another one he noted.
I guess my question is, who's got the responsibility for adjusting the knob?
I think the industry and the economics. So if it's enough of a problem, companies working together, if they're motivated to provide good experiences, particularly in these venues like stadiums. I can't remember if he said exactly where this was. Was this stadiums, Kevin?
Yeah, I think it was in stadiums. Yes.
It's a pretty unique environment, so I think they will bring the teams together to look at it.
Sort of along the same lines, we had some criticisms of the white spaces too, that the white spaces hadn't turned out to be as useful as the WISPs had hoped they would be. And I don't know whether it's a great question, Marvin. Does somebody have responsibility to try to fix that, or as Brian said, does the market eventually sort it out? Probably the latter.
Okay, Adam, go ahead with your question.
Yeah. So if I were to look at the pattern of where Wi-Fi is used today, distribution at endpoints on the network are increasingly important, and much of that has been consumer-oriented. With things like IoT sort of growing at a fairly fast clip, where do you see unlicensed bands, in fact, supporting our industrial activity, okay? And in particular at the higher frequencies, which really don't propagate that far and therefore can be contained?
Yeah, so we have not Kevin, correct me if I'm wrong. Yeah, it's an accurate characterization. We have been kind of, consumer. We haven't looked at verticals like industrial, and perhaps, it's occurred to me that this may be where we could use cross conversation with Russ's group. But yeah. Oh, and so I think I glossed over another thing we came across more recently, and maybe this goes to your question a little bit. There's more dimensionality to unlicensed than we've really captured here. It's in one of our slides, but there's also not just whether it's licensed or unlicensed. Where it's used matters. So is it indoor or outdoor is one of the things. So that's to your point, and the physics of the bands themselves matter. So I'd say we haven't really gotten there yet.
Okay.
Greg, you have a question. You're on mute, Greg.
Oh, yeah. Okay, thanks. So when you've got an input on sharing and dynamic sharing schemes, but what I've gathered is that when we share with each other, or FCC users share, we can use those schemes or require those schemes, but some of the frequencies that we're using or sharing with military are NTIA frequencies. So do you plan to get any input from them to see about improved sharing?
It's a great idea. We don't have them teed up yet, but it'd certainly be great if there's somebody from the military that would be willing to speak to us. My understanding is that there's a study at NTIA now on potential reallocation of bands, and that it's coming out soon. So maybe we could have somebody from NTIA address our group too.
Yeah, I think that's a great suggestion.
I do too.
Yeah, if you need help connecting, the liaisons can do this, or I can certainly help you too. Marvin, you had a second question.
Yeah, in TAC a few years ago, we noted that a number of IoT applications were running into problems because they started out using 2G or 3G, and operators were really reallocating the spectrum to other protocols and validating their equipment, which was embedded in long-lived assets. So we said, you really ought to think about using unlicensed for those kinds of IoT applications in long-lived assets. Is that something that you're still looking at?
Take that one, Brian.
Yeah, so I'd say not directly. I think it has the same, there's the issues that people face of how much control do I have over the band, and so one of the problems, although unlicensed has been used for some fairly critical applications. I think it's been used for meter reading, some other things. That I think that's one of the issues, is how much control they have. Now this issue of long-term certainty crops up a different way for us. I think it's creeping into the sharing discussion, Kevin, right? Of, the spectrum. How long can I make a business deal to share spectrum under certain conditions that two parties are comfortable with it? That complicates, I think, some of these sharing questions.
Yeah, that's a very interesting point. Yeah, no, we heard that from a couple of the speakers, that they would like to be able to do deals with the licensees of licensed spectrum, because those licensees aren't using their spectrum in their geography, and they're saying, why let it be fallow? We could use it for a while. But striking a deal with the licensee for the right time frames is challenging. even though the licensee may readily admit that they're not using the spectrum now, it's hard to set a time frame on how long they might not use it. And if you're a sub-licensee, how do you build a business if the spectrum is only available for a limited duration? So it kind of comes back to the sharing technologies again. Can you cobble together multiple frequency bands that you're going to use and be able to share them at certain times and have enough aggregate capacity that you could build a business around it? It's an interesting challenge.
All right, great. There are no incoming additional questions. Another really great presentation, and I really appreciate the insights that you're securing in this area, and we'll look forward to your actionable recommendations as you get to that end of the cycle. And with that, let's transition to our final working group, the Artificial Intelligence Working Group. And nothing artificial about the intelligence of the co-chairs, so please take it away, Lisa and Adam.
Okay. Let me start off with the following. I think Lisa unfortunately had a family emergency, so she had to drop off just before lunch and won't be able to join us.
Oh, that's so sad.
Okay, yeah. So I think, just have her in your thoughts, folks. So that's one. Second, I'm at a location where I lost power and it will not be restored until late tomorrow. My usual internet connection is not functioning. So I have to say, thank God for wireless and hotspots on cell phones. So I'm actually able to join and it's functional, and so far it has not dropped. Okay. So with that, let's do the following. We could move to the first view graph.
Alan, give me 1 second. As you're speaking, we're having a little bit of technical challenges, but go ahead. I'll catch up with the slides.
Okay.
Boy, your presentation is fettered on all fronts.
Okay. Challenge today, and I think in the background, if there's any noise, it's emergency generators creating a racket in the neighborhood.
Where are you, Adam?
Oh, Wayne, Pennsylvania. We had a storm come through last night.
Oh, right.
Really knocked everything out. So, okay. Okay, thank you. I see the view graph has come out. So I think what we're going to do today is look at the AI and Computing Working Group, the membership. I'll say a few words about that. A little bit about the calendar year 2020 charter and objectives. What our approach is. I think what we chose to do is share with you our in-process deliberations. They're quite raw in some respects, not very mature. We have identified some potential areas of recommendation, and in fact would welcome additional suggestions, both from our liaisons and the rest of the TAC. And then we have a working group white paper on AI in process. And then lastly, we'll get to summary and discussion. If I could have the next slide, please. So if I take a look at the working group, great attendance from the TAC. I think we've been very lucky for a number of the TAC members to help us vet a few SMEs to participate. What I'd like to do is point out Nagin from Himayat from Intel, who's actually running a sub-working group for us. We have Gabriel Lennon, who I think is on the line. Thanks to Dale Hatfield. He is an intern who will be joining us for the summer and doing a significant amount of work, essentially. And we'll get into that as we go on. I'd say, we are holding 2 meetings, one for one of the sub-working groups, and then the main working group meeting. And again, like to thank everybody for the input and great participation. Let's go on to the next one, please. Okay, so if we look at the working group charter, it's fairly general. I think compared to last year, it actually does drill in on some specific topics. So we'll discuss those next. And they're the context for what the rest of our presentation is about. So if I could go on to the next view graph, please. Okay. So the first one is that if I were to characterize this, there is quite a significant amount of investment on the federal government in programs in various agencies that deals with the evolution of AI technologies. Quite a few of them, in fact, applied to telecommunications. And, if you look at it, there are major programs at NSF, some of them jointly with industry that deal with AI, machine learning, and wireless networking systems. There are programs at DARPA, and there are probably relevant programs as we go through this presentation at around 5 or 6 additional agencies. And so one of the questions in this is, how can some of this research help inform the FCC? Where can it be useful? And what should the modes of interaction be between the FCC and the agencies doing this work? And if you look at examples of where stuff may be important, we just heard a lot of talk about spectrum usage in almost every one of the working groups that preceded this one in terms of delivering their presentations, ability to identify signals, detect and understand violations, preventing interference, improving the physical layer protocols and signal processing that goes on, and then as you go up up the stack, really things that deal with the whole end user experience. So the actions we have taken is to go out to the community, get some of the leading researchers to come and tell us what they're up to, including 3 of the winners from the DARPA Spectrum Challenge, who have done some fairly interesting work. By the way, 3 very different styles, as it turns out. So that's objective number 1. And what I would say is our sub-working group that meets on Tuesdays, the main one meets on Wednesdays. This is what Nagin is running at this point in time. Let's go on to the next one, please. Okay, the second issue, while somewhat amorphous at one level, deals with data, exploitation of AI techniques and algorithms lives on the data that you can get your hands on, how well it's looked after, and the many things that it can be applied to. So in one way, we're spending quite a bit of time trying to understand what would be reasonable data sets, how would you define them, how do you actually use some of the investments we may have mentioned previously by the federal government that look at various frameworks and methodologies for data setting, et cetera. Okay. Big question is, how do you make the data sets available? Because many of them may be proprietary, owned by the operators or intermediaries, but yet useful for the greater good. How can you collect them? How can you make them available to the community and assign a reasonable set of usage regimens to where the data can and cannot be used? Okay. So quite a bit of effort in this area. Let's go on to the next one. I think if we look at objective 3, fairly much a drill down. How can the useful information and data that's already available, combined with AI techniques, allow you to do things like coverage maps, understand service parameters at a much more granular level, and maybe end up being a mechanism for merging with other or aggregated data to do anything from improving the understanding of what our networks are doing, detection of fraudulent activities, and unauthorized spectrum usage. Okay, so we'll say a little bit more about that shortly. Let's go on to the next objective. Okay, and this is about applications of AI in terms of policies and I'd say partially using the bully pulpit that the FCC has. How do you take a look at AI tools? How do you promote their safe use? How do you deter deleterious actions of any kind? And how do you make sure that you build robustness into the AI methods and techniques so you don't put the network at risk? Okay? We have a subgroup working on this. It's David Tannenhaus and Nomi Bergman. So again, we will have a few words from them during this presentation. All right, let's go on to the next view graph, please. So our general approach is to develop use cases and identify important issues where AI can potentially impact the FCC, where it can impact the national telecommunications ecosystem, or where it can be an enabler for significant new economic activity. We have been conducting weekly meetings, as have the other groups. That's done Wednesdays at 4 o'clock. We have a sub-working group on the safe use of AI. It actually does its deliberations as part of the larger working group. And then, as I mentioned previously, we have a sub-working group on lessons learned from federally funded AI research. That's headed by Nadine, and that meets Tuesday at 10 o'clock Eastern Time on a weekly basis. What we've been doing is studying the issues and use cases, leveraging industry experts, analysts, folks from government organizations, the research community. There is a fairly extensive appendix that has our list of current speakers, and I would say the dance card is filled till the end of August, actually, with speakers at this point. What we've been trying to do is, first of all, sort of blow up the number of use cases we can think about, but then drill down, characterize, and prioritize them based on relevance to the FCC, relevance to the telecommunications industry or end users, and likely to have a significant impact in a reasonable time frame. And part of that filter is to understand the use cases in the context of the 4 objectives that we just went through. What we expect to come out of the working group is a final presentation, obviously containing the actionable recommendations aligned with the 4 objectives, and then a white paper, fairly extensive, that really captures the role that AI plays in telecommunications, partially as a information piece, but really sort of setting the background for the context in which we'll be presenting our findings. And again, the keeper of the outline for that is Negin at this point. I think we would like to share this, obviously, within the working group, but if there are any folks in the larger TAC that would be interested in parts of this and can contribute or have resources that can contribute, we would like to hear from them. Okay, let's go on to the next one. Okay, so these are our in-process deliberations. I would say what we've been building up at this point is an inventory of questions to ask. I think have a limited number of answers at this stage. But again, trying to be as disciplined as possible so we contribute to recommendations on the impact of areas of relevance for the FCC. I think that does require some knowledge of what it is that the FCC does and doesn't do. Some of our working group members are well up on that. I think for some of them, it's one of their first engagements. So I think the help from our liaisons who have been really terrific at this is extremely important. Okay, I'd like to thank them for all they've done at this point. I think we have gone through in this area to identify where the research is. I think pretty far along with that. I'm going to skip that. Probably not worthwhile reading all of this, but it's important to point out that there are a number of test beds that do exist as part of this federal funding, and depth of personnel familiar with AI, where it's used in telecommunications. So we see some potential value there. The next is, if I were to look at the area of recommendations, I would say, at a high level, the FCC needs to be prepared to exploit research for policy and rulemaking. In doing so, that means having certain resources in place, so we are considering that. And there are other organizations like NIST, NTIA, the NSF, obviously, DARPA, and so on. And the question is, how do you interact with the activities that go on in these other agencies? Let's go on to the next one. Okay, and I think for this one, originally we were planning on having Negin chirp in. I think under the rules we have right now, that seems to be difficult. But she is the person looking at this area. But the first question it sort of begs is, how familiar are the personnel at the FCC as to what the issues are in AI? What are they prepared to do? What are they not prepared to do? So we have been looking at issues that deal with that. Let's go on to the next view graph, please. Okay, so the next one deals with data sets. And again, this is such a vast space the kind of data you need to train an algorithm for something you're doing in the physical layer may be very different than what you're doing in the core of the network, the presentation layer to the customers. And so the first thing is we did some degree of scouting. There are some very extensive data set examples. There is a framework at NIST that's fairly broadly used. It has a lot of industry involved in it and a similar framework in the EU. And there is an important point to make here, and that is the practice of AI may result in an algorithm that you actually put into a piece of software with the associated hardware, but that may only represent 5% of the work that you have to do to make that AI algorithm useful. And it is that there is a tremendous amount of work that goes in around data, understanding its provenance, keeping it over its life cycle. So these frameworks are extremely useful, while not specifically not specific enough for the telecommunications industry. So one of the questions is, how do you interact with the folks who build the framework, and how do you mature it so it is in fact useful in the present setting? If I look at network-oriented examples, we're actually looking at a couple of different ways of capturing what kind of data is needed where. I think Mike Navratsky was going to put together one cut, which is along the lines of what the value chain is. Another cut, much more technical, is to see what kind of data fits where on the OSI stack, okay? So the value cut and vertical cut are the two things that we're looking at. Let's go on to the next one. Okay, so the next thing is, if you look at data, it has value to the owner of the data. It may also have tremendous value to others. So the question is, how do you create regimes and incentives that this data can actually be, how would I put it, shared and exploited as much as possible. If you look at what NIST did, part of it is having common languages, so developing the right kind of ontology or dictionary for the telecommunications world, fairly important. And part of that is actually capturing what it is that flows across the interfaces and how do we talk about it in some of the things you may have seen in the previous presentations. You know, a great one for us, for this group, was looking at ORAN and the well-defined interfaces there, because they're part of deciding, hey, this is what I would need in a data set to understand what actually happens, okay? And then if you were to look at the use of data in some of these algorithms, again, the ability to merge it, synthesize it with other data becomes increasingly important because those are the settings in which some of the AI algorithms may actually deliver value. Let's go on to the next one, please. Okay, so I'm not going to spend any time on this. I just want to say that when you start looking at data sets and all the things that go around them, this is part of the NIST output. They have published 9 volumes that deal with the data set. It's actually very well done material. So rather than reinventing the wheel, a thought was to adopt a framework like this and build what we do on top of that. Let's go on to the next one, please. Okay, I think we talked about this previously, so let's go on to the next one. Okay, and then I think what goes along with data sets are a whole bunch of policy issues that deal with things like privacy, trustworthiness, access to the data itself, and as I mentioned previously, how do you create incentives to be able to do this better? How do you calibrate the data? How do you make sure it's of the right quality and the right provenance? Lots and lots of issues along these lines. Okay? So again, early stage, I think we're developing a lot of the questions that go around this, and hopefully they're what then allows us to at least generate a few approaches which end up in the recommendations. Let's go on to the next one, please. Okay, and then I would say the next one was broadband mapping and the use of AI. The objective there is to see whether you can, in fact, use techniques of this sort, maybe some form of crowdsourcing, to be able to paint a much better picture of where spectrum is being used, who has access to it, and to be able to characterize it by the many, many parameters that go along with this. Whether it's something that's geographic, whether it's a unserved area, an underserved area, whether it's affordability that drives the adoption, to be able to really create significant sources of data, of information from the data, that in fact, shed some light on those kind of issues. So let's go on to the next one, please. Okay, so I think this is, I would say, much more sort of detailed, but it also sort of starts dealing with some of the technical aspects, okay, and that is, if you're going to provide better broadband, let's say in rural areas, things of that sort, what role do satellites play? What role does licensed spectrum play? Unlicensed spectrum? And what are valid market mechanisms that work in the various settings that we have across the nation? Okay, so let's go on to the next one. Okay, so we are going to hear from NTIA, and again, I think we're very mindful that AI is not the answer to everything, but it may be part of a larger solution, essentially. We also take a look at the FCC in this setting with the programs that it has, because it is also investing in the infrastructure to actually meet some of the challenges of providing broadband in a ubiquitous sense. Okay, next one, please. Okay, and at this point, I was actually going to ask David Tannenhouse to step in, and he was going to speak a little bit about safe use of AI, what it means. We didn't do very much of this in the first quarter. We have quite a few speakers lined up. In fact, I think we had one yesterday, Jason Martin from Intel, that are starting to look at various aspects of AI, where it works, where it doesn't, and just to make sure ahead of the curve that we don't get into situations where we built in vulnerabilities into the network. So David, if you could take over for a few minutes, please.
Okay, thank you, Adam. I just want to sanity check that everybody can hear me, or at least some people can hear me. Great.
You're quite
and yeah, and sorry to tell you that Lisa suggested about 4 minutes on this chart, so I'll go as quickly as I can. I won't read through all of the bullets here in terms of the issues to be addressed. You can read them. I will say the first three, trust, security, privacy, really are tightly interrelated. So those very much go together. The next kind of group of bullets, really all except for the last one, in many respects, have to do with, I think the need, as one of our speakers said, and it was a really great point, to think of AI and ML as almost a whole new type of supply chain. And that it's, like other supply chains, it needs to be risk managed in terms of security, vulnerability, and quality. So good news is many of those risks that come up, and these are risks, for example, you have risks, Adam talked about the training data. So your training data could be compromised, or the training data could not have been deliberately compromised, but be biased in an innocent but still inappropriate way. The models themselves are part of that, supply chain. And then the infrastructure that you run the training on, and that includes not just the hardware infrastructure, but the software infrastructure, the development environments that are newly emerging. Those haven't been hardened yet, so they likely have latent risks. And then the actual inference infrastructure that you run the kind of finished model on after it's been trained. So all of these are basically, parts of a supply chain that we're going to need to learn how to risk manage. The good news is a number of those risks are classical security risks, and we should, approach them using good security hygiene. There are, however, other risks that are very specific to machine learning. Most of these machine learning systems are basically seeking some sort of local optimum. So they're trying to improve efficiency by finding an efficient operating point, but it typically is a local optimum. It's not necessarily the optimum, and more importantly, it's possible for them to settle into a local optimum that either wasn't really what was intended or isn't desirable for one of a number of reasons. So those are kind of key sources of risk that are somewhat unique to machine learning. The good news here is it's not doom and gloom. There's kind of multiple approaches to managing those risks. I mentioned before good security hygiene for the things that are not unique to ML. For the things that are unique, one is to use models that are well understood and predictable. Unfortunately, the models that are currently all the rage, which are the deep neural networks, come in a bunch of different flavors, are not yet well understood. But even there, all's not lost. You can constrain or wrap those models. So imagine a wrapper that makes sure that the sorts of inputs that go into those models are inputs that are, in a range that is known to generate valid outputs or outputs that fall within desirable ranges. So those are examples of approaches that we'll be learning more about. So those are the sort of sources of risks. I guess I'd also like to speak to the bottom bullet here, which is it's especially applicable to privacy and to subsystems such as chatbots that users directly interact with. So this is a little bit different from some of the machine learning issues. One of the people who will be speaking to us, so it hasn't yet addressed the whole group, but we had a bit of a pre-brief with them, highlighted that in those circumstances, some jurisdictions are creating a essentially right for the public to know that they are interacting with a chatbot or they're interacting with a human being. These are examples of issues that will need to be considered in terms of public reaction and acceptance. So with this list in mind, there's also the question of what are the insertion points for the technology, because I think there's some very different types of insertion points that we need to consider. And the risks and mitigation strategies will vary with them. So I think of these, if we want to think of it as almost a table, a great output here would be a table where the bullets here are the rows. The columns are sort of based on different time constants. And so you could imagine that there's, a column related to things that happen and where the machine learning, is providing, say, reactions that are based on, say, hours or days. So this would be classical big data mining. And that could include, mining customer usage, billing, payment data. Those things are going to, for example, then have a very high privacy component that needs to be considered. In many ways, these things are that sort of mining similar to what other customers do with other companies do with their customers' data. But we have to be mindful that our communications are a very special type of information where the privacy requirements may be different and higher than in certain other areas. There's also this level of hours and days, other types of big data mining that will really relate much more to creating operational efficiencies, conducting business planning, et cetera. And the risks there are going to be related to long-term robustness of the network. So if you have a machine learning program that unwittingly steers you wrong about where you site your cell sites, that could be debilitating to the network for a very long time to come. So there's a very long time duration of the impact as well. So I imagine another column that is dealing with think of it as use of machine learning and things that have seconds to minutes in reaction times, like tuning the network, doing root cause analysis and reaction and remediation, doing threat detection related to network intrusions, things of that sort. And so then the risks there are related to unanticipated results if you use the machine learning in an unconstrained way. And the potential for, adversarial disruption, where adversaries deliberately have tried to fool the models. These things are difficult because now you're at a time constant where you're right on the edge of humans being able to intervene to, notice and make corrections if the ML is going wrong. And then yet another time constant is really much closer to real time, things happening in milliseconds. Researchers are starting to do things like insert machine learning models into TCP congestion control loops. So this is really happening on a per flow basis. It's happening near instantaneously. There's no hope of humans actually intervening to correct. So these could be subject to what I think of as very surgical strikes that create high frequency instability. So we're, going to have perhaps a different set of mitigation techniques for these types of threats. And finally, zooming out of all this, and there's a kind of a fourth time constant that some of my colleagues have pointed out, which is sort of the regulatory time constant, where machine learning is used to guide regulatory decisions. And there, I think some of the biggest risks, as Adam pointed out, relate to the training data. Either being deliberately corrupted or simply being biased or unfair in some way. And with that, I'll hand it back.
Okay. David, thank you. I think that was a good walk through what the issues are. So we have a lot of anticipation. And I will say we really have quite a few speakers on this topic. Starting with Stuart Russell, who's sometime in August, and folks from a number of the federal programs who are really concentrating on some of these issues. At the same time, there's sort of no substitute of sort of capturing what's going on in the industry at this point. And it really, I think, is important to get this across, that analysts who look at uses of AI somehow think of the telecommunications sector as being the lead sector on exploitation of these techniques at this point. Okay, let's see, my view graph disappeared. Michael, could we bring up the next one?
Yeah, somehow something happened. I'm working on it.
Okay.
Well, your presentation is cursed here today. Lisa's departure, your power out now. Now this. While Michael's doing that, I would also note that you have 9 slides left and -2 minutes left to present them.
I will say that the previous session went well over. But
not well over, but it did go over.
It go over. Okay. So let
it also went well.
It did. It did. Very well, in fact. Okay. So let me do the following thing without the view graphs. The next section is talking about potential recommendations, and we have looked sort of as a.
You're back now.
Okay. I'm going to skip this. Let's go to the recommendations. I think there's a triangular view graph. Okay. Topics. Keep going until, keep going. Keep going, okay? Okay. So if I look at the nature of the recommendations we're thinking about, the first set is really broad organizational AI strategy for the FCC. Okay, and what is fairly obvious to us is that AI impacts so many different aspects of what the FCC does that having that kind of strategy in place is fairly important, and it's fairly important to be prepared for the kind of issues that will end up in front of the FCC. The next thing is what I would call sort of broad issues around AI. And those are the table stakes. If you want to play the game, you have to have a hand in these. And then lastly, at the bottom of the pyramid, but maybe the most interesting, is what I call specific uses of AI. Whether it's use of AI to improve spectrum sharing, whether it's AI to identify sources of interference and do enforcement, whether it is the creation or encouragement of new business models that improve the marketplace for telecommunication services, whether it is specific protocols and management techniques for the network, whether it's methods for recovery of what's happened to the network, whether it's looking at I would say a rubbing of understanding what the spectrum environment is across the country. So, I think as you drill down from top to bottom, much more specific things. We aren't going to boil the ocean, so what we're looking for is to filter out and prioritize what are the most important things to do. So if you go on down to the next view graph, please. Okay, and so again, I'm not going to go and spend much time on it, but any contribution anybody thinks that we may have missed, not gotten, please tell us what it is, and we will put it in our deliberations, essentially. Let's go on to the next one. Okay, next thing is we do have a white paper. There is a fairly filled out timeline, outline for it. We have some folks who have volunteered to write sections. We would like to expose that to the whole TAC. And if you have any recommendations for improving the outline. Glad to hear that. Would be much gladder to hear anybody who volunteers to take on a section of it. Okay. Let's go on to the last one, which I believe is the last view graph. So in summary, you know, when we think of the nature of what we may be recommending to the FCC, the first one is said, be ready. You know, AI is not all mature technology, but there is a lot of it already deployed in the marketplace. There's a tremendous investment in this area. And I would say anticipating some of the things that are important to avoid unintended consequences of the use are fairly important. And I think if I look at the events of the last 2 weeks, after we wrote this this little blurb, something did land in front of the FCC that we didn't think was going to happen quite this fast. Okay, fair warning, and I think what goes along with that readiness part is that there are, I suspect, issues around AI that are not necessarily on the FCC's charter. If I were to look at an analog, it was the emergence of the internet, while the country still had the PSTN as the system of record. And eventually, that came out of the noise to dominate a lot of the considerations that the FCC has today. And then the last one is on leadership, seize the day, look forward, and exploit this technology as much as possible. So with that, I think we're done for the day. Other than questions.
It was an excellent sprint to the end. Very well done.
Okay.
Are there questions? There's been a dialogue going on the chat around this area from Russ and Nomi, and I don't know whether either or both of you want, and Paul Steinberg as well. I don't know whether you want to formulate some of your dialogue into a question or not.
Yeah, I had put mine in the form of a question up top at 224.
Yep. So please go ahead and
Sure. So should the TAC working group focus on AI trust, security, privacy? These have been and continue to be addressed broadly in the machine learning, data, deep learning, AI marketplace, as well as with researchers. The three topics are critical, of course, but my question is related to the limited time TAC working group has to focus on FCC-related use, application, and recommendations related to AI.
Okay. So, Russ, the best answer I can give you is we have actually lined up a group of speakers on this area.
I know.
I think they have something profound to say because this area in telecommunications is different than AI applied in other fields. And they'll specifically talk to that. And I think that's the rationale why this is an important area to pay attention to.
Yeah, but Adam, these are broad topics that are being addressed broadly.
I'm not talking about broad topics. I'm talking about drilling down and looking at specific impacts in our field. Okay, and let me give you an example. You could say that, you know, when it comes to the use of data for AI, there's lots of investment, lots of stuff has been done. Okay, when you look at general frameworks, they don't necessarily address the issues we face in our field. Okay, and if you take a look at the rules and the laws and the policies that the FCC has, okay, I think these three areas have a lot of profound stuff that has to be dealt with. And I don't think I'm the only one on this particular working group that feels this way.
Russ, I'll just jump in and say this is part of why I'm trying to break it into these time constants, because I think then to start looking and saying, okay, what's unique to telecom? You know, if it's, as I said, say got to do with per flow applications of ML, right? That's pretty unique. What are our concerns? When it's got to do with certain other areas that are more operational but longer time constants. I just feel like that's a way of breaking it down and kind of forcing ourselves to think in terms of specific telecom applications of the technology.
Yeah, but David, I could make that argument for any AI deployment across any of the verticals or use cases. And I think, you know, when you look at, to me, there's an analogy or parallel to telecom. I mean, telecom's becoming a cloud-centric network. When you look at a lot of the cloud applications, I mean, whether it's advertising, whether it's retail, whether it's, you know, customer satisfaction, whether it's chatbots, whatever. I mean, these are topics that I think the team shouldn't spend too many cycles on. I mean, yeah, they're important. I agree.
Well,
100%.
look, let me do the following. I think let the group vote on that, okay, rather than dictate what we should and shouldn't do. We hear your vote, but I think there are other opinions on this, Russ.
Okay.
You're the chairman of the working group. I'm just providing a question, some input, my viewpoint.
Yep.
So thanks
No,
for
we heard it.
Yeah, I think we've got it. We can move on. Are there other questions? Hearing none, and given the hour, we'll thank you very much for Adam, especially with the challenges that you have undertaken to present this. I will point out that, and this is sad to say, Russ, but you only had 42 slides while Adam had 51, Russ and Brian. So your observation, Russ, in the chat of the number left, 51 of those were, in fact, Adam's, and therefore he has 9 more than you did. Kevin
you
and
have a little
Tom,
competition. I think the rest of the team realizes, but the aggregate total at the end of the year is what will count.
It's fun. It is interesting too. I would note that both your group, Russ and Brian, and Lisa and Adam's groups are continuing, and you were at 42 and 51, where the two new groups were at 16 and 27 slides. So there is something, I guess, that goes with people who have been at this multiple years. So anyway,
but we did
learn bad habits.
Yeah.
What's that?
I said we did put a lot in the appendix.
Yeah. Yes. No. That's absolutely right. No, and they're all independent of the. This is where we're not in the room, so you can't see the smile on my face. But all were excellent presentations, and all captured a great deal of information. But you certainly do it in different ways. So that's fine. That's part of the diversity of life. This brings us to the close, and I know that Ron Rapazzi has been kind of multiplexing today, so I'm not sure whether he is on or not to give us a few final words, but if he is, this would be the point at which he would be invited to do so.
Thank you, Dennis. This is Ron, and I was able to catch the AI slide presentation, so I was able to weave back into the discussion here, and I take it that there's been some pretty good discussion based on the comments made about the number of slides and the time going over and that sort of thing. So I trust that everything went well, and there was a good dialogue among the working groups and throughout the TAC participants. I will definitely circle back with Michael and the individual liaisons to each of the working groups to get more fidelity on the specifics of the discussions in the earlier slide presentations. But I go back to my opening remarks where I feel like a lot of work, a substantial amount of work and effort has gone into getting us to where we are. And my appreciation goes out to all who've been participating in these pretty much the state of the art and beyond the state of the art technology topics. Thank you.
Great. Thank you, Ron. Michael, would you like to provide a few words of wisdom and guidance?
Yeah, thanks, Dennis. I mean, this is a tremendous amount of data and information that everybody really contributed well. So, and also we were working all online during this interesting times. Just want to make a note that the next tech meeting is going to be on September 22nd. I'll be sending out an invite fairly soon so that you will not put anything important on that date. And at the same time, you know, we will see what the calendar, what the environment allows us to do, whether it's going to be virtual or not. I guess the time will tell. Other than that, I don't really have anything else at this point. Thank you, Dennis.
Okay, thank you, Michael. I will echo the point that these really were great presentations. Although I've been involved in some of the groups and catching the sessions as I can, bringing it all together, you really are almost overwhelmed with the amount of information that has been captured and coalesced in the way that has been done and has been displayed for us today. And naturally, that has enhanced our collective understanding, and obviously the objective is to also enhance the FCC's understanding of these topics, and I think that has and is happening, which is terrific. And that leads to a set of thank yous. First, I want to thank the co-chairs who presented and brought everything together for us today. It is a lot of work that the co-chairs take on, and not only running things, but organizing the activities and sub-working groups in many cases. And I would recognize the sub-working group chairs as well for their contributions, and the TAC members and the company subject matter experts that have been brought in and vetted through the new processes that we have this year. But I think there's a tremendous number of contributions that have been made that need to be recognized. In that space, every year it just seems to get better in terms of the speakers that we're able to attract. The speakers, I mean, always have been great, but this year it just seems like we are getting the person who knows the most about the specific topic that's being addressed. And that's a real kudo to those who have reached out and brought in the various speakers, because they've really contributed a great deal, and much of their material has been captured in the presentations today as individual slides. So that's, you know, really terrific. I also want to recognize and thank the amazing core of liaisons that we have. I think this is the biggest year, the largest number of liaisons that we've ever had. Michael can vet that comment for me, but we really have an amazing group of liaisons who have been not only contributors, but have helped to make sure that we're steering the boat in each of the working groups in the right way and overall moving forward. So kudos to each one of the liaison group. Finally, I'd like to thank Ron Rapazzi and also Manisha. Manisha has been very, very actively involved as our FCC Chief Technology Officer. And I suppose, Manisha, I should give you an opportunity to say a word or two as well. Do you have anything you would care to share?
Sure. Thanks, Dennis. I have actually enjoyed I try to catch as many of the different groups as my schedule allows. And I agree with you. The speakers have been terrific. The material that's been presented has been absolutely top-notch. And I think in each of the groups, we are really getting a nice rounded picture of what the state of the art, not only in industry, but also in R&D is. And that is extremely valuable perspective for the FCC to capture in a very short time. I mean, we're trying to do this in 4 very different areas over really, a few months. It's not even a year that we hope to get some actionable recommendations. And it's been great. The progress so far has been really nice.
So, Manisha, you are the most active of the CTOs, at least in my experience, which is the complete experience of the TAC.
Well,
so
you know,
really
I think each of these topics are near and dear to my heart as a researcher as well. So I'm really learning a lot and really enjoying it.
Great. And finally, it goes without saying that things would not work at all the smooth way that they do without Michael Ha. Michael keeps us all organized and efficiently moving forward, including the meetings. I don't know about the rest of you. It seems like I'm on virtual meetings constantly these days, sometimes 4 or 5 in a day. But the TAC meeting is one of the largest of those gatherings that I'm involved in, and it runs very, very smoothly. So, Michael, kudos to you, and kudos to the team that back you up at the commission to make sure that things are running smoothly and that we capture the information for future as well, because it's one thing to capture a meeting video-wise and all when you are in the commission room. It's quite another to do it in the virtual manner in which we're meeting now, and the team there are accomplishing that. But Michael, we thank you for organizing all that and making it happen.
Yeah.
As to
the note for the Richard, Jeffrey is sitting behind the rooms or in his office, supporting all the commission room staff, getting all the captions and slides and everything else working properly as well.
Yes, thank you. This is just terrific. Michael's already highlighted the fact that our next meeting is the 22nd of September, our third quarter meeting. By then, hopefully, we will have beta level actionable recommendations, not the final ones, but we'll be homing in on those. And so that's the objective and challenge, even as you continue to gather a lot more information. Each of the groups has presented the large number of speakers, not only that you have had, but those that are just off stage and prepared to come forward over the next set of weeks. So that's something for us to all look forward to. Beyond that, I'd like to wish you all a very enjoyable summer, as we seem to be very much into that. And though I have these sorts of sentiments normally, they have much more meaning this time, and that is a wish for each of you to stay healthy and to be safe in this crazy environment that we're in, and stay productive as well, because that's what this is all about. With that, unless someone has a final comment, we will call it a wrap. Any final words, final thoughts, Michael?
No.
Okay, then that is it. And regardless of the bantering about times and all the rest, I would note that we are finishing 5 minutes early, so you get 5 minutes added back to your day.
Thanks, Dennis.
Thank you,
Thanks, Dennis.
You all.